And when you start to see what's coming out of each and every plant, then you can start to prioritize, close those plants which are perhaps closer to populations, close those plants which are emitting more than they should be doing. This is a project we're doing in Indonesia. We have ranked over 120 plants, every single plant in the fleet. We have estimated the emissions coming out of those plants, and that gives us a chance to prioritize which ones should perhaps be closing down before the others. Also, for plant operators, you're going to have to comply with the NOx, SOx particulates, and finally mercury emission limits coming up. Unless you know what your emissions are, there's no way you can judge the best practice for reducing those emissions. For some plants, if you understand your NOx emissions, you know that by changing the way your coal combusts, even blending coals can get you to that NOx emission limit without spending money on SCR and SNCR. Knowledge is power. The more understanding you have in your emissions, the more you watch them fluctuate as you change your plant operation, the more you'll be able to have that insight to get more cost-effective emission reduction, especially with flexing plants. When you start to flex your coal plants, your NOx emissions are going to go haywire, and you really need to get a handle on those. So Sanjeev and our friend Wojciech, who's based in America, and I have produced a summary document available free, one-click download from the website, which summarizes the challenge for India. The fact that you're setting these emission norms at the level, the same as the emission limits in Europe and America, and you're fast-forwarding to those. That's an immense challenge. And at the same time, in order to record those and monitor those emissions to ensure that you're complying is also a challenge. So we've summarized the challenge and we've looked at the way you're doing it. And from what we understand, you have a combination of both the European and the US approaches. And that, to us, opens up a wealth of variability to suit your environment, but also a wealth of challenge because some of you will be using different techniques to do the same thing. So you've created a problem, but also a solution. And we would hope that we can encourage you to work together to create a more Indian system. You need to set up your own national legislation, your own national standards, and your own national training scheme. Because what works in Europe and America will be interesting to you, but it might not be totally appropriate. So this is some of the data from the report. For what we're seeing, you've had to put, as far as I understand, Cems on your plant since 2017 onwards. You've had to apply, and they're reporting online. And what we're seeing is this is data for 2020, so it may well have improved since then. But this is data for your particulate monitors, for your SOx monitors, and for your NOx monitors. And what we're seeing is in green there, that's the number of your Cems that are working correctly and reporting data in real time as they should. In orange, we have plants which are telling us that you have the Cems in place, but they're not working, whether they're offline, whether they're not calibrated, whether you've just not switched them on yet, I don't know. And then there's the little bit in yellow where we don't know what you're doing, we don't have the information. So what we're seeing is, although in theory you have Cems in all your plants, you're not getting the data from all your plants. Something is going wrong, and so that's why we're here to help you. Possibly a lot of these Cems can just be fixed by a little tweak, by a little bit of calibration. Ask us. If one of your Cems is on this because it's not working, ask us and we will help you fix that Cem. So what we're seeing is, this is data that I've stolen from Sanjeev, because Sanjeev is the knowledge when it comes to Cems in India. We're seeing improper calibration. We're seeing inadequate or inappropriate setup of the equipment. It's not where it should be in the stack. It's not in alignment. We're seeing a lot of issues between the machine and the regulator, that data transfer. There's something hiccup happening in between there. And there's no data validation for the data. Also, you don't have a certification scheme for you yourselves. As far as I'm aware, there's no Indian standard for a stack tester for us to prove that you know what you're doing when you put that in. And hopefully the training you will get this week will make you the experts in India on stack testing, and you will improve in that information and share it. But the ultimate aim would be for you to have your own certification scheme within India so that everybody's working to a benchmark level of performance. So you've got these new emission limits, which are extremely challenging to go from sort of no emission limit or SOx compliance coals down to the limits you're seeing. That's going to install a lot of FGD systems. I don't know if you're aware, your particulate monitors are mainly opacity monitors. They won't work with an FGD system. You're going to have to rethink that and move to different particulate monitors. You're going to have to buy monitors that get down lower than the levels you're emitting in terms of particulate SOx and NOx. And ultimately, mercury monitors are going to have to come because you have an emission standard for mercury. In order to prove compliance, you're going to have a monitor or some other means of demonstrating compliance. As I say, you don't have international standards. You have international standard methods. You don't have Indian standard methods. I think it would be a good idea for you to set up a working group to establish those. And we do have a meeting next week in New Delhi where we're bringing stakeholders together, and we hope to find funding to set up a standardization project in India for certification for stack testers. If you're interested in that, please come and let me know, and we can certainly share the information on that. So on to the interesting stuff. The training format. You, as I say, are going to see more than 500 slides today and tomorrow. There's going to be an awful lot of information. You might not take it all in during the days, that's fine. You will be emailed those presentations. You will also get hands-on training. Those that can come on the site visit, we can't take all of you. As I'm aware, there's a system for making sure that regulators get priority to go on the site visit. We will have the stack testers there, and you will be doing some experimental calculations to show how it's done. Answers, time for questions and answers. We're trying to build that in, but if anyone overruns and we run out of time, do talk to us during coffee breaks. Do talk to us at dinner tonight. Do email us. We want the information to be there. And you will get this exam tomorrow. You will get an exam paper, and we will work through it together. It's an open book, open mind exam. The trainers will be here. We will ask the questions. We will discuss amongst ourselves what the answer will be. And I think you'll probably pass, but we'll see. We'll see. In order to get your certificate of passing, we need your exam back. We also need the feedback form that you'll be given. I will only give you a certificate if you've given me feedback. We've got another one of these workshops to run, and if they're taken well, hopefully we'll get funding to do more. So we need feedback on what we can change, what we can improve, what we did wrong and what we didn't. Also, we want to understand your challenges. You might not want to ask a question, but put down in that form, I can't get my particulate monitor to do this, my span is drifting, what's happening? And we'll come back to you with the answers on those. You will get the answer to every question you have. I promise you we'll work towards solving all of your problems. So it's the open book exam, hand it in. Full slide set will be shared after the events, and we will email your certificate. So this has gone wrong every time I've done this. You give me your feedback form and your exams, and you've handwritten your email address and your name. And I'm not very good at reading some handwriting. So I cannot beg you enough, please print your name and your email address, otherwise I can't email you the certificate. And if you don't get the certificate within a week, email me and then I'll have your email address. But it'll be easier if you can write clearly on your form. As I say, we've had feedback from previous events, and I've just listed some of them here. Some people are confused over the different approaches of the US EPA, where you can use any monitor as long as you can prove it works. In the EU, you have to use a type-approved system. People having issues with maintenance, especially after the vendor is gone. We're seeing the vendor putting it on there, giving you some training, and then they're gone, and you're left going, but I forgot, what do I do? We can help with that. Repairs and availability of spare parts. We're hearing there's a lot of delay on replacement and repairs. Perhaps we can do something within the working group we hope to set up to, I don't know, mend that, make it faster, who knows. Problems due to power outages, and what do you do with the data for that period where there's no data? There are means of filling that data. And also concerns over data security. We've had questions about, okay, that data is going straight to the regulator, but is there a chance somebody could be hacking into that in either direction? We want to answer those questions as best we can also. So as I say, these are some challenges and questions we've had before. Happy to answer them again. and happy to answer any new questions you may bring up. I'm going to stop talking now because I am not a stack tester. I'm just fascinated by the subject. And I'm going to hand over now to Sanjeev Kanchan. I think if you don't know Sanjeev, then I would be surprised, as he seems to be the centre of information when it comes to Cems monitoring in India. And he is the man. I may stand up here and pretend that I created this meeting. Sanjeev did all the hard work, so all thanks to Sanjeev. Thank you, Sanjeev.
Good morning once again. You had good tea, coffee, I guess. It's a little bit rich. We have just started. So if you are a little tired after 3-4 sessions, I can understand. Right now, you have to be open. So good morning once again. Many of you already might have attended some Cems training program, what APPCB had organized or other organizations have organized. But this is a little different from that. In initial training programs, what we have done, we have discussed about how you select the technology, what are the available technology, how the guidelines work. So those were the basic things. After 8 years of installation, we have come to a point where we see the challenges in the Cems implementation is not superficial anymore. You have little detail, you have to get into the little detail to understand those challenges and rectify that. Agenda of having this program, we just selected 4 programs that is supported by United States US Department of State to have 4 specialized programs where we are talking more detail in operation and handling. Selections, you have the guideline. They have the certain instructions that how you install, how you correct. We will do that one as well, but our focus here this time is operation and maintenance. How you correctly calibrate, how you maintain that equipment, how you operate that equipment, which is, that information is missing in India. We haven't have it because we started 8 years back what US and EU has done 40, 50 years back. So I had been lucky that US Department of State could provide us with some of the funds. So by the time they fix this, uh, so this is the program we planned it that will focus this time on operation and maintenance. The basic things we have covered many of the times before, and you can also get the idea from the guidelines. From the guidelines. So this program we tried to involve more of the sessions, if you see, is mostly on operation maintenance. And one of the important part of it is, as our guideline says, that you have opportunity to have US EPA approved, US ECA approved methodologies, not Cems, or European system of certification. Both ways we can have the Cems. So our guideline just refer that you can refer the US EPA method or European Union methodology for quality assurance. But what all that methodology about? How does they do it? So we will discuss in that in detail. As Leslie has already conveyed that you will get the presentation, but my request and my suggestion is do ask the questions as much as you want. It is more to clarify. Documents are written. You can avail from any other sources, but you have the people here for 2-3 days. It's important that you discuss with them, figure out the things. There are multiple ways to get the answers. Through, you can get here, you can get through email, or different ways you can connect to them and figure out the answer. I'm just trying with my presentation. I have done it many times before to you, so I'm just sharing some context. So the speakers, experts who have spent 30-40 years in that field, they will tell you about all those things. I will just be a supporting person here in this program. So this is about Cems in India. I just like to remind you that now, since February 2014 till now is almost 8 years. Scenario has changed a little bit. The market had grown to almost, if you see, 800 to 900 million US dollar, just for equipment installation. That much, 8 years of experience. That's the last point, but I am coming into the first, connecting you the dot. Still, we have multiple problems. In last 8 years, we are having the Cems, we install the equipment, we are invested in the operation and maintenance, but this data is not still being used for the compliance check. That is not a legal method of compliance. You still get through manual monitoring, which is sent to the board, pollution control board, and that is checked against the stipulated norm. Why it is not being done? The problem is we still do not have that much of confidence on the data. Why there is not confidence in data? Because the data quality is still not good. Why it is not good? Because we haven't learned, we have not improved mistakes that were made. It is logical. It is not that we were fool, we made mistake. 30, 40 years back, US and Europe started. They improved by the time, and there's still scope of improvement. India started 8 years back. But it would have been wise. We learn from their mistake and not to repeat those mistakes again. So we have in India now, you monitor air quality using from stack emission using Cems. You have CAQMS for ambient air quality. You have water and wastewater quality monitor, which is CEQMS. Around 30,000 installations, if you are not clear, around 30,000 installations are among these 17 categories, which was the guideline or direction from CPCB. So that data is directly coming to the CPCB in parallel with the respective SPCB. But beyond that, many of the boards, many of the state pollution control boards have asked beyond 17 categories of industry, which is rate category industry. 60 categories are there, 60 types of industries are there, beyond 17. So they are also supposed to install the equipment. Some of them are like NGT has asked in Delhi NCR that all the industry has to install. Like you know, in Gujarat, there is emission trading program for PM. So that is beyond the 17 category, they are asked to install for that which is happening, emission trading scheme. In Maharashtra, there is a star rating program. So for that, they are also asked. So there are multiple other installations. So the number is huge. And beyond that, Ministry of Environment and Forest is focusing much more in air quality expansion of the air quality network. So just in 2021-22, nearly 4,400 crores were allotted to that to set up that network. And it is a project which will be repeated every 2 years like that. So it's huge investment from the government side as well. That is for air quality. So we have a lots of installation, but still we are at the same point that we have the problem, and the problem is leading us to not to have the good enough data quality which we can use for compliance. You have this list, and if you don't remember, the latest, the guideline, Cems guideline, which was developed. So in 2020, August also, that they have added some new things. But this is the final, the parameter that you monitor. One of the important thing, if you focus here, is there are two raw power plants and thermal power plants. Both are same, but in one you can see they have added total mercury. So there's no clear explanation for this, but as far as I understand the explanation from them, mercury is required for the industry where you have been given in emission, environmental clearance that you have to monitor. So for that, you need to have Cems installation for mercury. Otherwise, you can monitor mercury, but Cems is not required. But those where emission environmental clearance says about, you have to install for mercury Cems as well. That's the explanation from CPCB. And many of the explanations you might have heard from the vendors, but I'm not debating on that. But that is my clear explanation which I want to convey you. So these are the guidelines that you have seen. CPCB has also come up with the compliance reporting protocol. It has not been implemented properly, but this is one of the things which, going further, it will be used. So how much you are complying, how much percentage of data is going to comply with the norms, accordingly you will get alert, red, yellow, like that. So it will be implemented pretty soon. You have remote calibration system now, and I would like to tell you this is one of the good things that we started from the basics, and we are very good in manipulation, tempering the data. That also led us to devise some new things. Like this remote calibration, it doesn't happen anywhere. Normally, it doesn't happen in a majority of the countries. It's not a very big deal, but at least we thought something out of the league. So that remote calibration is something new. And one of the good things for India is data handling system that we have, like the data from the monitor directly goes to CPCB, directly parallel goes to SPCB, you can access in the parallel. All those things are quite advanced. Again, quite advanced compared to the Europe and all. They do not have this kind of systems normally. So the normal system there is, the data is sent to the regulator, to the industry. Industry supplies the data at whatever intervals they want. We have quite good system right now. So we are doing some good things in some places, but we need to learn a lot. So these things you already have, and that is one of the, I would say, point I would like to highlight is whatever data acquisition and handling system you are seeing, it is being further updated. So the system which is already in place, it will be updated by a new data acquisition and handling system where it will be more automated, more control by the central regulator. This you know, so that is what you install. I'm coming to Cems only, so either you have in situ in the stack, or you have extractive out of the stack in the duct or somewhere you install. You take the sample and monitor. You have this. Data acquisition handling system, we have quite advanced, as I said. So you can, using Cems, your CQMS, your AQMS, all the data through same channel or data acquisition handling system can be shared to the CPCB, SPCB. And you have the access on the mobile, you have access on every officials can have access who is authorized to see that data. So this is quite advanced system, but still it is improving. You already know that this two-way data transfer system, which is used for calibration, remote calibration. Remote calibration, that's the only difference here it is, the data acquisition system is directly connected to the equipment. There is no intermediate server or PC in between. So if there is, regulator gives a command for remote calibration, that should directly go to the equipment. Equipment should respond like this. So if I'm sitting in here, if I give the command for zero test, zero gas should pass and should reflect to the zero. It is not like the instruction goes to, or signal goes to a data logger kind of place, and they send you whatever you want. We are very good at it, but that is how the two-way data transfer system and direct connection of data has been devised. This is one of the good systems for sure. Guidelines, I'm just summarizing. From the Indian part, you will have a detailed presentation on guidelines by one of the speaker, Mr. Kamyuta, ex-member secretary of CPCB. He will do online. He's not well, but he will do online. So to summarize this guideline part, In India, we can adopt either United States system, which is you install any equipment. This is your responsibility. But when you are installing, you have to go under a series of tests, which we call a performance test. There are multiple tests under the performance test. That is what we are going to discuss in this training program. What are all those tests? What is the frequency? What that test means? So that we will get into the detail of that. So we go under the performance test. But in India, that is the point which is missing. We require to do that. Guidelines tell us that performance test is required. But who will do the performance test? By third-party laboratory. But third-party laboratory has to be identified for this, has to be accredited to do this. We right now do not have. So EPA or NABL accredited lab is doing their job, but that is not actually their job. They are not trained for or evaluated for that. If you want to install the certified equipments, mostly from the Europe, you have certified multiple supplier here is also there, so you can have those equipments. So this gives you a little bit credibility in the sense that these are already tested, but these are tested in the lab and the different environment condition in Europe, not in India. Indian environment is different. In the operational environment is different. So when you install here, it is not like that you can just fix it. This is not a plug and play. You install the equipment, you have to calibrate it to that situation, to that gaseous condition in the stack. That's what we are not doing. What we do normally, if you experience it, we install the equipment, we do calibration, and in the name of calibration, 0 is span. And we say we did the calibration. So 1.0, 1 point span, 2 dot is always a straight line. So we are always happy. Whenever we do the PM monitoring, we also have the similar kind of concept. We avoid multi-point. So we do 2 dot, straight line, calibration perfect. 2 dots are always a straight line. So we have to improve on that part. So we have to do, even if you have certified equipments, you have to install it and test for certain parameters, go through, which our expert will tell you about, that is called Qual 2. What are the test requirements, how it to be done. So we have some guidelines, but how it is to be done, that will be shared by the expert today. India, when we started in 2014 with the guidelines, it was said that we will have our indigenous certification system. Some work has been done. It has been asked to NPL to develop, but unfortunately, I'm not very hopeful for another 7-8 years now. We are trying to build up as Leslie said, a working committee, technical working committee in India, where we will try to bring up something or draft something or work out some of the problems that we have, and we'll offer some solutions to the CPCB or ministry if they can go through it. So meanwhile, that working committee, that will be informal, that is not a legal part, will be informal, where problem from industries or problem from vendors, technology suppliers, or from the regulator, those technical committee can discuss. So that could be the expert from India, that could be expert from different countries. So there are a few people here, your speakers, they're representing some of the advanced societies, technical society in Europe and US. They have agreed to give us some support in that, in technological support. So once we need some kind of solution for the problem, we will be able to discuss and develop. But this is very initial state. I'm just giving you some hope that will improve. So these are the guidelines which CPCB Cems guideline refer that you have to follow this. But saying this, we are expecting that we know everything of this. Right? We refer from all the US EPA documents, we know everything. It is not possible. That is what the problem is. Our CPCB guideline says we will follow this, but who knows this? We are not expected to know everything of US EPA document. And if you go for one document, documents never finishes. So it goes to 600 pages, and every one page it will refer to another document. So it's a difficult part, and we are expecting everyone to learn. So we have to have our own experience and simplify, come up with simpler solutions. This has already been explained to you. There were initial problems because you know the guideline came 3 years later. 2014 we were asked to install, 2017 the guideline had come. By the time multiple mistakes had been made. Mistakes were related to the correct selection of the equipments. Then installation of the equipment. Installation is not only that where to install in stack or duct. In the stack or duct, also you need to see with reference to the gravimetric monitoring point, sampling point. With reference, you have to see each other equipment which is installed, because one equipment may affect the performance of another equipment if it is not correctly installed. So correct installation, or maybe length of the probe or direction, all those things makes it important if you need to have the correct data. So how to install, how to select equipment, how to install, where to install, correct setting. Even now, after 8 years, I'm talking about the big industries, still where the norms are 50 to 100, I still find they have to set the range of 1000 milligram. Everything is covered. But that you cannot set. Even if 4% or 5% of difference, if drift is there, 4%, 5% of 1000 is around 50 and 60. That is more than what they are required to monitor and comply to. Still that problem is there. Tamper-proof data transfer, I think this is not that much common, except those who are determined that I will do that. Industry are not doing that much of these kind of things. But the data which is coming has to be proper. That credibility is still missing. Quality assurance is that certification. Certification, that is quality before you install that qualified equipment. And once you install, then you control the quality for calibration, for any drift check, etc. So these we have to understand. These were the initial challenges which we had no idea. Meanwhile, in last 8 years, we improved many of the things. But these are the superficial problems. Now the problem has gone into depth because we started understanding the data. These initial problems were seen like this. If you see the photograph, one of the photographs, these all are real photographs. There I have plenty of that, but I'm sharing just the simpler one to you. So this is PM monitor. If you see, it is all covered in the white. Many of you might have seen this photograph already. So it's not giving any data. Data was stagnant because it's not reflecting or is not sensitive to that what emission is coming from. There was one funny installation on the bottom. If any one of you can identify which equipment it is, this one, red brick chimney, and there's an installation. You can get the Nobel Prize if you can identify it. So in that stake, that was in fact, I went for NGT to do some monitoring. That is in Delhi NCR photo. I'm coming from that side only. So I went to see that with my colleague. I asked to see whether data is coming perfect. So when we saw, let's see where it is. So I saw that. I went up, I saw that. So there's no probe, just these wires. So I asked them which company it is installed. So I'm not telling you the name. So this company installed just few months back, and we are getting perfect data. Data was perfect. And there was no installation in that. So, and these wires are giving all the data you want. Luckily, it was only PM, SO2, and NOx by the time. But if you would have asked mercury, VOC, or anything, that would have been also come from this. So that was an installation. And the surprise thing when I asked, when you installed it, I know that there's no installation. There's just electric data generator. Somehow they generated the data. So I asked them, did you calibrate this equipment? Yes, during installation we calibrate. And the funny part is, that stack has only one porthole. So the person who came to install, he found that hole, and he installed that thing in that. So there's no another hole. So how did he do the calibration? There's no way of having the manual sampling anymore left. So even the industry didn't know that. So there was no other hole, and he did the calibration. It's not problem that industry lied. It's a problem that he didn't know about this thing. And whatever was said by third party, whoever installed it, he understood that. So one of the point is not that somebody cheated him. The point is we didn't know the fact what is required to be done. That's the purpose, that people should understand what is the equipment is, how should it be installed. That last part, that was a brilliant electronic idea some guy had developed. If somebody of you can recognize, please keep it to yourself or share with your colleague. I am not going to tell the name. If you see that box, it was installed, in the same plant. So the data was coming from that. So if you see that, so when I went to the site and I figured out how the data is coming, or if the equipment is like this, it should not come. So say data is coming, and the data was varying. It was going low and high. So I said, how does it happen? Finally, he found that something has to be said. It has to be declared. And because the industry had invited me, I found that. So what has happened, if you see three holes there, they're plugs. He said on the top, if you put on the top, you will get higher data. Middle one, middle data. Lower one, lower data. He declared that this is the solution we have found. And this solution was given with the equipment by the equipment provider. Now you decide what to be called. So I don't know if it has been removed or not, but I said you remove it immediately. And if you have this thing, don't call me, otherwise I will report somewhere. This is pathetic system. So that is how it is happening. It is not about he cheated. It's about he had invested in the equipment. He is sending the data. So nobody is getting benefited of it, despite the investment has been made. And someday industry will get caught because he is responsible for the entire thing. Some of the big installations, initial, it might have been improved by the time. As I said, where to install, incorrect installation in the sense of, if you say, first is you install in a stack or duct. Preferably, even now I say, if you have right position in the stack, because when you make a stack, you fix that platform, you fix that porthole, etc. So that is the best point, best site to install, whether it is gas or PM. PM is more sensitive because you have to install at the right point for the isokinetic condition, stabilized flow, so that you get the right representative data from the emission. Point of installation is again very important, whether it should be above the gravimetric monitor, whether it should be at which angle compared to the temperature, pressure, or SO2 or NOx, which direction. So some of the presenter will share you about. We have in the guideline, but they will explain you all those things. One of the installation I found is one of the biggest plant. So here you see if you can see that there are two ducts joining to the stack. So there could be two ways of monitoring. One, you install in each stack, which is double installation, that's the thing. Or you install in the stack where all the gases are coming. So to cope up with that, somebody had installed in between. So it is representing everything. But the point is, when gas from two ducts are joining, it's opening to the bigger portion, then it is opening to the stack, then there is no stabilized flow, right? There is cold spot, the flow is not stagnant, flow is not uniform. So that's the wrong point. This has been made. Another power plant, one of the biggest power plant in Punjab. There are 4 monitors installed, 2 monitors only for PM. We are struggling to install one, they had installed 2 at the same point, but we're not getting the data. Emission was visible and data was showing 15-20 milligram. Problem was with the monitor, but the thing is, the duct was coming from the bottom, and just 5-10 meters it is connected to the duct, so it is going like this. And there is an ID fan. Entire thing was shaking. They have installed the equipment. How do you expect to have the stabilized flow at that point? The problem is we cannot go on the stack, or it is not the safe spot. But that doesn't matter. That installation has no meaning, because your equipment which you have invested into is not giving you the data you wished from. So these kind of installation problems, maybe vendor was not aware of this, and not very serious to that point, or industry is certainly not aware, because they invested for 2 equipments because data was not coming correct. But still the problem has not improved. I'm not going to another state, so I'm taking example of Delhi NCR itself, what is happening. This was you had seen installation, some of the installation in the stack which I had been to. So there was no installation, as I said. The industry didn't know. So this is the installation. 2 ducts are joining just here, they have installed. If you remember, the guideline says 8D, 2D, right? That is where we do PM monitoring. 8 dimension in downstream and 2 dimension from upstream between that space, because it will give you the stabilized flow. That is the right spot for at least for PM. The installation was wrong. In that one, we asked to just do for monitoring how you do. So none of the environmental official or technology official was there to go to the stack. He sent a laborer. So a laborer will do now the calibration. That was the condition. Because they never thought that I have to reach on that place. So they had installation, but they were not, even not there to go that. So will you be able to maintain that equipment? Makes no sense. Your investment is gone. And no, you are non-compliant for sure. Third was hilarious. So as I said, you had seen the pipes coming from, and they had said, we have a cabin for analyzer cabin. Analyzer cabin was locked. There was no light. There was just a fan, and they switched on the fan, they opened that one, it was dirty. There was just a computer left, because there was no analyzer. It was not installed there anyway. And they had no clue. They hadn't gone back and seen where the analyzer or anything is there in their plant. They paid them. Yes, instead of 20 lakh, they paid them for 8 lakh, and every solution they got. They needed data. You do whatever you want to do, give me the data. So that was the solution was. So this kind of installation is still there. This is one of the biggest steel plant in India. It is the initial photograph, not right now. They have improved it for sure. But you do understand this is one of the biggest steel plant of the India. We went to visit. That was the first training program. We were there with CPCB officers and some of the selected officials from different PCBs. We saw the data of effluent quality monitors. So data pH was perfectly 7. You understand that perfectly 7. It was not moving. All the time it is 7. So I said, how come it is so perfect? It's not changing. Again, so they took us down. We went down. We saw this situation. They had installation. They had good quality of equipment installed. But all these equipments were installed in such a place there was no water. The idea was whenever we are discharging, maybe intermittently when we discharge, that is being monitored. But thing is, they do not discharge. Since they do not discharge, everything was holding somewhere. It was dry. Equipment was wrong. That was fixed to 7. So it was not working. Equipment had gone. They had to replace those. So the thing, it is not like they installed at wrong point. There was no requirement of installation at this place. So they installed additionally. They invested for nothing. They were supposed to require to install after ETP, where they just treated and then they use something that is reported. So they had installed the outer channel, no requirement needed. They install and it's not working. This is why we need to learn. These are the basic things that we had in the beginning. Data handling, you might have seen many times. These are the old slides. Things have improved. So the first slide, as you said, it is data clamping. So this was initial. There are multiple cases of that. So there was norm of 50, and industry was providing 45. Perfect 45. And if the regulator asks you why it is 45 all the time, no problem, take 42. So next time it is 42. Some of them were identical. If you know that if you are sending data, you are monitoring data for every minute, so there will be a graph. But if you average out for 15 minutes, graph will change, right? So 10, 15, 20, that number will get averaged out. Both were identical. Is it possible two different numbers having the average identical? It will not be. It will continuously identical. So it was generated. Another one, if you see the data on larger scale, you will find data is continuous. But when you get into the detail, you will find data is every 2 minutes is coming, 3 minutes gap, 2 minutes is coming, 3 minutes gap. But so overall, if you say the data availability will be very less. These things industry can observe at their end, regulator can also analyze that. That was one of the fun things. He might try to be a little smart, the person who did that. So if you see, what is the BOD norm normally? 30 milligram? COD? 250 milligram? So in a wastewater, normal wastewater, you generate. If you see that, BOD is yellow line. COD is green one. So in order to show the flexibility, he increased the BOD beyond the COD. So BOD crossed 250. COD went down. So this is new kind of wastewater combination has generated. Later he realized it doesn't vary like that. So these are the things you can also figure it out. One of the most, I would say it is invention. You get certificate, right? When you get certified equipments, you get certificate with that. Normally, vendor will give you a certificate. In real, the certificate is, this is the front page, backed by 7, maybe 60 page or 100 page, 50 or 500 pages, which tells you about what all tests have been done, how the test result, what are the formulas has been used. Everything will be in the detail. Normally, equipment provider will not give you, or maybe give the first one. So that is the, I observed, you see the first slide. So that one industry came to me, he was just got trained. He had been training, gone back, he had to install one equipment, he called back, we have got a certificate, so I do not understand what certificate is this. So is this, they said it is a certified equipment. So can you please figure out what is the first photograph, what certification it is? So I'm sorry, it is not that much visible. It's 9001. So that guy give this certificate to the industry. It said my equipment is certified. 9001 is quality management system for industry. There has nothing to do with the equipment. But he was so confident that industry doesn't know all this, he sold that one. Second one, this is the real time. How does it look like TUV certified when you get it from Germany, TUV Rhineland or TUV Sud like this? So this is just the front page. So it talks about all those formulas, all those regulations under which it is tested, how it has been qualified or not. So all those details are there. Second one, there's also some which you got, equipment you got tested in the laboratory. Laboratory test is random testing. You got equipment tested and you install it. It is fine. It is saying that your equipment is working, but it is not saying that equipment is working in all the time, all the conditions, throughout all the conditions, right? It may vary because you just did a random testing. Certification testing is done in the laboratory for 3 months. They install 2 parallel equipments in the industry, they run it for 3 months or 6 months. So a certificate which you get, it may take from 6 months to 2.5 hours, a half year. So it gives a range of data, and from that it is understood that, okay, from this condition to this condition, this equipment will work perfectly. Or for these many months or these many years after that, you need calibration. So that is how that certification is done for the equipment, which gives you assurance. But if I take my equipment, test it in the laboratory, and I say this is my performance, and it is fine. But it doesn't tell you that equipment will work like this always, or will work like in the different environmental conditions and different gaseous conditions. So certification and random testing is different. So if somebody is saying that I've got it tested, this is your certificate, that's not certificate. Certification is different. As I said, the initial challenges you have seen, that has changed. Now the point is, there are many stacks where there's no space of right installation on the stack. Stack is old, you cannot make hole, or you cannot go to that point, so where do you install PM? Or where you install the monitor? So you have to find, there are different other ways, like you do stratification testing in the duct, and you find what is the nearest accurate point, if not as accurate. So there are tests to be done for this. And then you install in that place. Because ultimately, installation means you have to have a spot where you get representative sampling, representative monitoring. Second is improper calibration. In the name of initial calibration when you install the calibration which is done that point of time, which is in Europe is called Qual2, there's a range of tests. It's not just zero and span. You pass zero gas and you pass span gas, that's just not the calibration. So there's a range of tests. You will learn about that. Many of non-performance tests, that is non-performance means in case of non-certified equipment, you have to go through the range of tests. Wrong measurement range, I already tell you, still continues. I see that there are some technology providers who still have the intermediate PC, so they give to the regulator or they have with us. CPCB declines it, they do not want it, but I don't know how it survives. When you get the data, this is one of the challenging problem is when you get the data, Cems monitors in ppm or milligram meter cube, right? Our norm is milligram normal meter cube. To normalize that number, you have to convert that ppm or milligram normal meter cube standardized against temperature, pressure, moisture. If you do that, that number goes 3 times. In many of the industry I saw, they were perfect. My NOx norm is 600. I am getting only 300. He doesn't know that what you are getting is milligram meter cube or ppm. When you multiply it, it goes to 3 times. You are already non-compliant and you do not know. There are conditions like this. This will be explained by the speakers. So this is how when you have to install multiple equipments, like you have in incinerator, you need to have PM, SO2, NOx, you have HCl, HF. All those equipments has to be installed with reference to each other, which direction, which point. it will be explained further. So this installation is also one of the critical point. You have to install, in our guideline says 8D, 2D, right? In Europe it is says 4D, 4D or 5D, 5D, somewhere in between. But their stack height is also different. Our stack height is 275, up to 275. So their stack height is also different, so you have to follow. It will be, I'm not going into the detail, they will explain you that. As I said, standardization is one of the challenge. If you see in your plant or if the regulator can see whenever they get a chance, I just giving you an example. This is an example. So if the number, like here, you are getting conversion from wet to dry condition, because our norm is milligram per normal meter cube dry. So we have to remove moisture. We have to standardize temperature 25 degree. We have to have the 740 pressure. So if SO2, the value was 120. It was kind of real example. I'm just changed the number. So people do not get very directly. So 120, he was very happy that he has complied. So that was basically ppm and had 15% moisture. So when we made it dry, if you see the formula there, we did how much percentage is weight, remove the moisture, that 120 turned into 141. When we converted from ppm to milligram, SO2, that 141 turned into 403. That is for molecular weight you divided. Or there you can simply have the funda of dividing, multiplying by the number 2.6 or something like that. When we changed, we standardized against the temperature and pressure, 740 and then 25 degree, that 403 turned into 587.9. And then if we do 6% O2 or 10% O2, here I had done just 10% O2 for straightforward, simple calculation. That 587 now came to 530. So initial, he was happy to have the number of 120, I'm complying with 300 pretty well. But actually he had a number of 530, and he was not aware of that. So standardization is still some of the challenge in some industry. So you can certainly figure it out. This, Dr. Leslie has already included. It was for thermal power plant. We collected data for the entire year for 2021 for all the thermal power plants, almost all the thermal power plants, 70–80% of the India. I know that most of them have installed. I would say 99% have installed. But the data when we got, we accessed for entire year data, every minute data. Entire year, we got only 50% data is coming to the regulator. Many of them, with some or other problem, data is not coming. Maybe equipment is not working or some or other problem were there. So despite installation, right now it is not strictly being checked for data availability or compliance, non-compliance using Cems, so you are surviving. But this condition is not going to prevail all the time. So it's better we learn in time and improve. And if you are not doing that, you are also reducing the life of the equipment. Your investment is, if it is not perfectly working, maintenance, if you buy a new car, you do not run it properly for 6 months, you will not be able to start it. The battery is going down. There are multiple problems will happen. So you also need to run it. So at the end, what you need to have, right equipment, you need to select. We still have to improvise or not, we need to learn that. Equipment, it is your choice, you select the certified equipment. If not, non-certified, but non-certified has to go for performance test. Ultimate motto behind it is the equipment which you have bought should have credibility, giving you the assurance that it is a quality equipment and data you are getting is the proper data. That's what the purpose ultimately is. And if you got that equipment certified or non-certified, you need to ensure and it is correctly installed. This is one of the major problem, installation problem. And once you install this tamper-proof data system, I'm not very confident on that. It will take a little bit of time for us, but it is not such big problem now, I believe. This is the major problem. 80% problem comes from regular operation and maintenance after correct installation. If you have all these, data quality will improve. It will save your equipment. It will increase the life of your equipment. It will give you compliance. It will have the right purpose of your equipment for industry as well, for the regulator as well. And then it can be used for the compliance check. In this condition, if compliance check is planned, it will be missed. That's how it is not in the system right now. And ultimate purpose is, like in US or UK or many other countries happen. This is, as Dr. Sivareddy sir has already told, ultimate purpose of it is going to encourage you for self-monitoring. Industry should self-monitor where I am. You are the best person to monitor yourself. So if you have this system in the place, you will be able to self-monitor. Regulator don't have to go after you for everything, do this, do that. If you are doing it, that's how other industrialized countries are doing. They are not after that. A system is established, you are getting data, you are sharing data, you are complying. You maintain your thing because you know best how to run your plan. And if this system is come, that the ultimate system is self-regulation comes in place. A country like India with such a huge installations and expanding industry, it is not feasible for the regulator to just go micromanagement of your plant, your pollution. The ideal condition would be you manage it. But for that, a system has to be created which is ideal. That is the requirement. Keeping this in mind, we also need the capacity building throughout for the regulators, for the industry. That's what our purpose is. This next purpose, this training is especially different from the previous one. We planned it such a way. In the first day, today's program, after this, you will get through the basic guidelines, which will be presented by ex-member secretary CPCB. He's doing it online. Then you will learn about quality assurance. That's how performance tests to be done for non-certified equipments. That is US EPA way. And European way, how you do qual 1, qual 2, qual 3, all the tests, how it is done. Even if you got the certified one, what all tests are required to during installation and after that. Day 2, tomorrow, we'll have the basic data handling system. That is a small presentation on that. It will be followed by PM installation. Basics on PM technology and how you install it, how you operate and maintain. Focus is on operation and maintenance. That is missing right now. Calibration. Today and tomorrow, these are the two mandatory days for all the participants, so you must attend in order to get the certificate. And by the end of the day, we will have the assessment, CSAS test, so no need to be afraid. I'm confident with the 2 days of program, by the end we will have this multiple choice paper, we have to submit it. So if you ask in backside that, can I get a certificate without test? No. So don't come to me. So we have to submit that paper. But I'm confident. But you also don't be try to be outsmart and you do it right now. I do not have given, that's why I have not given that paper. But let it complete. There are many things where we are not clear. We always get dubious this answer or that answer. So you will realize at the end of the day, there are answers you were knowing it was not the right answer. That is some answer is different. So most of you, all of you, I would say, will certainly get clear. You will get good score and you will get the certificate at the end of the day. Third day, we have industry visit. Even you are from industry, I'm sure you will not be able to happy to attend these many people all in the industry at one go. So industry has, requested, and it is possible just for regulators. You have industry, you are experienced to it. What we will do in industry, we are supposed to do, that is not mandatory for anyone. We have only, maybe we will go with the regulator only. Some of you, if you are so, into that, we can try to figure it out, but we do not have a space. So we'll only for regulators. You are free to roam around if you are from outside. So that is not mandatory. In that, we'll do some manual sampling. We'll explain the people how does it do. Just trying to explain those all things. But having this crowd, we have also arranged that we'll bring that PM monitor, the trainer tomorrow who will come. He will explain you all the details here itself. So you are not missing anything in the industry. So tomorrow, I think APPCB will be the right people who to tell you. But industry visit is not mandatory for all. We do not have that much of a space, and industry also doesn't want. Most probably, we'll go with the regulator only. So it'll be free. Tomorrow assessment, your job is done. You will get all the material, maybe in a week or 2, and certificate as well in your email. So after assessment, in assessment sheet, you will have the space for email, etc., where you fill it perfectly. So you get the right name in your certificate, and you get the certificate directly in your email. So now it's a turn of some Cems experience, which I think Sivareddy sir or somebody is speak you about Cems experience in APPCB. My job is done. Now you will hear all the experts further onward. Thank you very much. Sir. Yes, you will get everything. That I can't promise that I can give you immediately. No, all those slides, I confirm you that if you just go through, if you listen the presentation, those questions are related to that only. All the PPT, all these other documents will also be shared, not only PPT, other documents will also be shared.
There are a few slides which are very important, like 17 industries and then documents to be referred. Those I feel to be reviewed by candidates.
The problem is you have just registered, many of you haven't given the right email, many of you do not, so I cannot send everyone. That's the problem right now. And I have to arrange for your dinner also, no? So if you want to have dinner or you want to email, so I will try to share, you can get, so all that what I have said, it is part of the Cems guideline, CPCB guideline, it is there. Sir.
Thank you, Ms. Sanjeevi, for throwing light on the Cems. In fact, just right now I have been asked to make a presentation on the experience of the APPCB. In fact, I don't have any presentation as such. I think that rather than going to the presentation, it is open for the both regulators sitting in front of me and also industry. If you have any queries regarding the Cems and your relation with the regulators as far as the Cems is concerned, you are free to ask the questions. I am here to clarify those things. Anybody have any questions? If you don't have questions, at least I will throw some light on the Cems as far as the APP is concerned. You are aware that it was started as a voluntary instrument in the 2014. Certain industries have been asked to go for the Cems. Subsequently, in 2017, CPCB has come up with the guidelines for the Cems installations. Even till date, it is not mandatory. I mean, it's not legally bounded. Whatever the Cems data are getting, those are not legally bounded as such. Based on Cems data, I am not in the position to prosecute the industry. It acts as a only source for us. Once you feel that Cems data is the indication, based on that, we will go for the physical monitoring. We will carry the physical monitoring as such. Isokinetic sampling, we will take. Similarly, gas analysis are done. Based on that only, you are in the position to go ahead with any legal action as such. So, in fact, Ministry of Environment and Forest has come up with the draft guidelines, making the Cems as a part of the system for monitoring. Subsequently, somehow it was not materialized. No notification has come forward as such. Still, it is they are working on those things as such. One more thing, you are aware that all our environment regulations are the criminal regulations in India. Now, right now, Government of India has thought of to make a lot of provisions decriminalization, so that they will impose a penalty rather than prosecuting the industry as such. Once it will happen, I hope that government will come up with the regulations to make the Cems as a part of the act as such. That's the reason. See, you are aware of that. This Water Act and Air Acts are deal with the criminal, whatever the offences they consider as the criminal offence as such. In Water Act and Air Act, courts have not enforced to let the convicted person without the conviction as such. Whereas in the EP Act, you have the provision. Either court can impose a penalty or they can impose imprisonment as such. That provision is not there in Water and Air Act. That's the reason I think that most probably that one of the reason why they have not made the Cems as the mandate as such. Anyhow, now the government is thinking to decriminalize most of the provisions of the acts, and once it happens, they will come forward. As far as Cems is concerned, see, all the industries have installed the Cems, particularly 17 category of industries, major red category industries have installed the Cems. In addition to Cems also, major water polluting industries have installed the effluent quality monitoring systems as such. As Sanjeev has told, see, you have the one cell in AP pollution. You are fortunate enough. PCB has not well equipped to deal with this particular subject. That's the reason nobody is getting the real pinch or pressure from the board. In fact, first and foremost, board themselves has to equip properly to deal with the Cems issues as such. Right now, we outsource the job to knowledge agents or vigilance. They used to call 1 or 2 persons sitting in our office. They used to monitor these kind of things. Even though we have some cell, no full-fledged persons have attached to this particular cell. That's the reason even PCB has to, internally they have to reset their priority for the Cems. See, basically, as a regulator, once you have depend on the Cems, there is no need for officers to go for the field inspections. Somehow it is not happening since data, whatever data are getting is not accurate, is not reliability of data is very questionable as such. So still people are depending on the physical verification as such. That's the one thing. See, first you have to set it house within the PCB is concerned. As far industry is concerned, I have already told, every industry now provided the Cems or affluent quality monitoring systems. Only thing, see, 2-3 months back, I have some assignment on the Cems and affluent quality monitoring. Then I have studied the data available in the board. See, can you imagine anybody is there from pharma industry here? I think that some people are there from pharma industry. Treating pharma affluents, how difficult it is, everybody knows it. Once you go through the data of all big pharma industry, every time it's showing within the norms. So once it is within the norms, both the industry is happy, regulator is happy. How it will happen? See, treating the chemical effluents, how tough it is, how can you maintain the consistency of data of which always below the norms? As far as I am personally concerned, if there is a variance, if it exceeds the so-called norm of 30, whatever it may be, then only can say that the data is accurate. So there the problem becomes. Once it exceeds, you get the notice from the board. So both board is not happy, both industry is not happy. That's the reason they have completely tampered the data. One is the tampering, second is the, he already told, where is the guarantee that that has been put in the right place, right stream. See, most of these are the not institute. These are the, you are taking, extracting the effluent and putting some kind of system. Where is the guarantee that you are extracting the same effluent which is going through the channel? You have your own method of the routing the effluent to a particular thing. That's the reason always you are getting the results within the norms. That's the first and foremost thing is that once you are getting the particularly industry like pharma industry, getting the norms always within the norms means it's totally something totally wrong with the system as such. You just go and check. I think the history also available with the industry. How many times it exceeded? Nothing. Always within the norm. Not only BOD, not only COD. Any parameter, name it. Those are all within the norms. Thus, first and clearly indicating that something is totally wrong as such. See, I already told, board was not well equipped to deal with this kind of thing. That's the reason why the industry is so happy as such. If the really board is equipped with, if they have the will, it will never continue in future as such. So I request the industry, please kindly saturate the things within their premises. Once you exceed the norms, you can say, yes, during the disturbance in the process, during the overload, it will happen. See, when you are running the industry, when you are running the treatment system, basically most of treatment systems are the activated sludge processes. So you are dealing with the living organisms. You can't have the 100% control over the living organisms. There is bound to be some kind of variation. If the variation is there, then only you can say that system is working, including your ETP also. It's indicative as such. Please kindly note down that particular thing. Already it never happened. Meeting the norms 24/7, it never happened. Similarly is the case with the Cems. For the take example of cement industry. They have the starting. They used to start the system. When they're starting, these are bound to be disturbances, bound to be emission should be always more than the what you have stipulated for 30 or something else. So once you go through the results in the PCB monitor, whatever it may be, always show the within the norms. How it is possible? So here is the mistake lies with the regulator, mistake lies with the industry as such. So suppose some variance is there, this regulator always issues the notice, irrespective why it was happened. It never check. So system was designed in such a way that if you exceed the 30, you get the SMS as such. That's the reason why industry also following some kind of things which they are not supposed to be followed as such. So it's a time for you to settle all those kind of things as such. Morning itself I have told, a lot of people have engaged in the service providers. See, basically these Cems or CAQMs are installed in the big industries. where the well qualified persons are available within the industry as such. For you, there is no need for you to depend on the third party as such. You are well equipped. If people are well equipped, you can handle those things very easily, providing that you have some kind of support from the equipment supplier. That is not happening. See, always they are engaging the service providers. What is the job of service providers? Only their job is that to satisfy the regulator, satisfy the industry. Always to project the rosy picture as such. That's not correct thing as such. Always, as a certain morning, always please kindly engage the service of the equipment supplied themselves rather than depend on the service providers. No, that's more important as such. These are our exercise. In fact, this is a very complicated subject. It's not that much easy subject. Particularly, this sense, particularly, I want to tell, no, particulate matter issue is concerned. It's totally depend upon the calibration. Morning itself, Sanjeev has told that European is talking about the KL1, KL2, KL3, AET. What is KL1? Calibration at the time of manufacturing itself. They have the lengthy procedure for it. As you told, it will take years together to get that kind of certification as such. What is KL2? When installation, you have to go for take example. You needed the calibration of 9 samples at 3 different loads. So 3 into 3, 9 samples for each. Then only you get in the position to get the realistic figure as such. See, I will take one example. We have verified one industry. They have the 10 stack mounting analyzers are there. 10. How much time it will take for carrying each stack? They have to take the 9 samples. For 10 stacks, how many? 90 samples. How much time it will take for the isokinetic sampling? For testing velocity itself, it will take half an hour. For taking this sample, it will take 1 hour. So for together, it will take 2-3 hours for each samples. The gentleman who has carried this kind of performance test for all the stack, he will finish the job in 1 or 2 days. Is it possible physically? So that's the reason. Until unless you have thorough knowledge about the issue, things will happen like this only. Only simply they have taken 1 sample, they say that they have taken the 9 samples. They have taken the same value as that. So calibration is more important as far as Cems is concerned. That's called KL2. KL3, what it says, during operation stage, frequently you have to test the performance of, suppose there is a change in the drift, it's gone behind a certain thing, then in such a stage, again you have to go for the 9-point calibration as such. So what is AET? Ultimately, it has to be edited. What was happened throughout the year, it has to be edited. That's the reason you have to aware of the what is KL1, KL2, KL3, AET as such. Similar way, American experience is concerned, they are going totally on the performance testing as such. They are not recognized the certified equipment as such. They have their own procedures. As I already told, India is adopting both models, hybrid model. They can go for the American style, they can go for the Indian style. Still, we don't have our own certification system in the place. In the absence of that certification, we are following the ESCP guidelines and EU guidelines for the monitoring is concerned, for sense monitoring is concerned. So these are the issues who are incurred in the field as such. As far as PM monitors is concerned, the basic thing is in PM monitors is the dust factor. How you arrive this dust factor? Again, you have to go for 9-point samples. What is your output of 4 into 20? What is your output? Based on that, you have to arrive at this dust factor. For that, you needed the 9 samples. As the morning is told, once you have the 2, always straight line. Once you have 9 samples, it's a different curve as such. Based on that, you have to arrive at the dust factors. How many people arrive at the dust factors? See, the consultant will come, they put one dust factor in the system. Industry is not aware, regulator is not aware. They simply put one dust factor. The service provider will come in between. Suppose it is exceeding the norms, you simply bring down the dust factor without monitoring the system to project the compliance as such. That creating a lot of problem as such. As for the two-way communication is concerned, that is meant for the basically gaseous sampling as such. For gaseous sampling, you have the system of remote calibration. So by sitting in my office, I am in the position to calibrate, check the calibration of the equipment. But once I trigger the thing from my office, so I am in the position to know what is the zero, what is the span, what is the different range of percentages. So that's one way. But unfortunately, I already told, 3-4 months back, I have an assignment to work on this thing. I tried my level best to do the remote calibration. First, they told that there is some kind of problem in the industry. Then I contacted the equipment supplier. Equipment supplier saying that I had told, some service provider has to attend certain things. When I contacted service provider, then they are saying that the particular equipment has no provision for the remote calibration as such. So what is the fun of having the regulation? Our regulation clearly saying that you go for the remote, you have the provision for remote calibration, you have the two-way communication system in the place. In practice, it is not happening in the ground as such. Please kindly understand this kind of things. Until unless both industry and regulators are aware of this kind of things, so nothing will happen as such. This remote calibration is one of the best system designed by the CPCB or designed by the government of India. If it really works, then the chances of manipulation will be come down heavily as such. There is no scope for the industry to manipulate the thing. When they manipulate the thing, you can easily identify it. Some of gas is there 1680, their upper limit. It should be reflected 1680 with some kind of permitted variation as such. If you can get any different figure, it clearly shows that you have tampered with the data as such. Similar way, as far as the PM is concerned, we don't have the provision for remote calibration as such. Whenever you go for the site, particular regulators, they have the lenses. Lenses for different concentration as such, 60% concentration, 70% concentration, different concentration. You have to put the lens, just check it, whether it's indicating or not. If there is any difference is there, it's clearly indicating that system has been tampered with. See, this tampering happens in different stages, I've already told, since I have the assignment on this thing, I've observed this. Issues at different stages. One stage is to tamper with the equipment. Second stage, you tamper with the so-called factors as such. Third stage is tamper with the transfer of data as such. See, one of the examples I will tell, particularly for regulators, how they have to check whether equipment is tampered or not. See, as previously Sanjeev has told, normally when the norms are 50, your upper limit for that is 3 times of these things, so 150. You should not be 1,000, you should not be 10,000. Once it's 1,000, 10,000, it will give the erratic figure as such. Presume that, suppose norm is 50, we presume that industry has put the upper limit of 200. Once I ask the industry to bypass the system, bypass the so-called control system. See, particularly once you go for cement industry, it's 80 grams. Once it was bypassed, it goes to 80 grams, whereas our norms is 50 milligrams. Where is 80 grams, where is 50 milligrams? I have checked in one industry who have bypassed the system. Even you never touch the even upper limit, the so-called 200, whatever it may be, it never touches the upper limit. It was only confined to 100 or 90 like that. What is it clearly indicating? Equipment has been clamped. So until unless regulator is aware of this kind of things, so it's very difficult to ensure the performance of the Cems equipment as such. See, basically, hardly PCB has 100 engineers. A lot of people feel that we are overburdened. That's the reason we are not able to deliver the results as such. As personally I am concerned, 100% is more than sufficient for small state like Andhra Pradesh. Since you have the technology in the position, use the technology. This technology, what is the next question? How to make it perfect? Technology, how to make it perfect? Once you perfect the technology, there is no need for the regulator to go to field itself. So one person can handle it. One person can handle the 100 industries as such. So you have to use the technology. You have to make it as perfect as such. Similarly for industry also. So simply providing Cems is not a solution as such. Until unless you regularly monitor the health of your equipment, whatever data you are getting, the reliability of that data. Similar way, you have to ensure that system should be properly working as such. See, basically people are an impression, industry are impression that these Cems are meant for the regulatory purpose. There you have to change your mindset as such. Regulatory is the secondary purpose. It will give the performance of entire production as such. Suppose one parameter exceeding means it clearly indicating that there is something wrong with your production system. Suppose, take example, similarly, there's any power plant. Once it's exceeding the norms, what it is getting? Your combustion is not perfect as such. There is a disturbance in the your system. So it's an indicator of even your production systems. It will act as a to find out the faults within your systems as such. So it will have the multiple purposes. Industry has to think that it's not meant for the only regulator. It's meant for they themselves. It will act as a, to increase their production, to know the real problems. It has a multiple purposes as such. Once you industry feel that it has its own advantage, definitely there is no need for the regulator to check the reliability of the data, reliability of the equipment as such. So it's a win and win situation. If the industry realizes that it has the twin advantages, there is no need of this thing. As I already told, why it was gained the currency in the Western countries? People are trading in emissions. Once you go for trading, you have to ensure the quality of data. See, otherwise you ensure the quality of data. The gentleman who was trading with you, he never pay. He will come and check, verify it. Once this will be gain the currency in India, definitely there is a lot of scope for improvement of the performance of the Cems as such. So that's the basis for any trading. That's the basis for the trading as such. So that needed to be encouraged. Even one way industry can earn a lot of money by going for the emission trading as such. At the same time, that will benefit the regulator a lot. See, somebody is also looking the quality of the data and system operation as such. That's the need of our, as far the country is concerned. With this, I request the participants, any questions they have, both for regulators and the industry. If you have any query, I try to answer those queries as per knowledge I have in this field. Please kindly raise your queries.
Questions? Now you have opportunity to speak to your regulator directly.
Before raising question, introduce yourself so that I
myself-
have a fair idea.
Yes. Myself, Karthik, I am from ArcelorMittal Nippon Steel, which produces pellet plants. My question is to regulator. Do you authorize any of this, the Cems supplier, whether you authorize any this particular, he is capable of, there won't be any issue with the equipment? That is one. And also, do you authorize any, the service provider? Because industry won't be like to spend more time on analyzing the sample at least. We take the help of service provider only to get the details as early as the possible and the right values. And industry is not ready to spend so much money and time on getting the analysis right.
I got your point. Right now, see, I already told, no, certification in India is not at all launched as such. Once it was certification launched, then you are in the position and panel, certain equipment manufactured as such. Right now, India is allowing both certified equipment, non-certified equipment. Once you have certified equipment, you have to follow the EU norms. Once you have the non-certified equipment, you have to follow the US norms as such. See, it's for the supplier to demonstrate, similarly it's the industry to demonstrate whatever equipment they are installing is meeting the norms. For that purpose, they have been given the liberty to engage the whomever supplier is there. As you rightly told, as far the calibration is concerned, somebody has to come and do the monitoring as such. I understand that every industry has not that much of expertise as such. For that purpose also, we are expecting the CPCB to come up with the impaneled persons for this kind of calibration. Right now, we don't have this thing. People are depending on the existing laboratories recognized by the central government or CPCB or government of India. Right now, they are working on it on both these aspects, both the certification of the equipment and empaneling the persons who are authorized to do the calibration as such. They are working on it, okay?
The precise answer you are seeking is neither APPCB, neither CPCB, they do not recommend any supplier. They do not recommend any service provider. It is your vision, your capability to identify them. You check them, you taste them, whatever you do, but they are not recommending anyone. Questions?
My name is Murali Mohan Kumar from RNL Visakhapatnam Steel Plant. And my question is two case studies. First one is regarding old chimneys. And the second one is regarding if we build a new plant, whether Pollution Control Board is vetting the document that chimney is having the structural locations for installing the new equipment. Is the design is appropriate or not? That question. And the second one is regarding the old chimneys. For doing any sampling and all gravimetric analysis or putting this new equipment in line, we need to have provisions in the old chimneys. Whereas in power plants, we will have a single chimney, so many boilers. So always any one of the boiler will be running. We don't have any shutdown time. How can we give the structural modification to the chimney to install this new equipment?
See, basically you have to do your internal modification as such. See, basically you have the guidelines where it has to be installed. You have to stick on to those guidelines, 8D and 2D, whatever it may be. You stick on to those guidelines. There is no shortcut for it. You have to change whatever the changes needed to be carried out, that has to be carried out. There is no shortcut for it.
Means if we do the core cutting, the civil is saying that refractory lining inside may fall out, like that in the old chimneys, they are objecting for.
That's exactly what I told. You have to follow the guidelines. Whatever the guidelines has indicated, that you have to carry out. There is no shortcut for it. Then only you get the real world data. Otherwise, the purpose of installation cells will be defeated. Okay?
Sir, as you rightly mentioned that the continuous emission monitoring system is not only for the mandatory from the pollution control board point of view. It gives the benefit to the industry. Such mindset to increase in the industry, is there any plan from the APPCB so that they can arrange some discussion so that industry will see like that this continuous emission monitoring system gives the benefit to the industries, not for the mandatory purpose? Because what happens right now, whenever the industry is thinking this is mandatory things, we have to put whatever available in the market.
Yeah, that's exactly what I have told. Now, once the industry realizes that there is money out of this particular monitoring system, particular trading system, there is no need of regulator to look into this thing. See, somebody will look into this thing. Somebody who was purchasing or this thing, credit, that person will look into it. First of all, industry has to understand the purpose of Cems is not for only regulatory purpose, it's for the internal mechanism. There is a lot of scope for earning the money. Even Sanjeev has told, these Gujarat people are even going for the particulate matter trading as such. A lot of scope is there. Please kindly study the international market as such, go for it. It will benefit the industry as such, okay?
Right. Any more?
Good afternoon, sir. My name is Manish Jaswal. We are Hindalco National Limited. Actually, sir, we have installed hydrogen provide monitoring system. We need to know how to calibrate those systems on site because HF gas itself is very unstable.
Pardon?
We have installed HF monitoring system in our plant.
Which monitoring?
Hindalco National Limited.
Okay.
Okay, aluminum plant. So we need to know how to calibrate the system on field.
Sir, whomever supplies system, the gentleman will guide you how to you have to carry the calibration as such. That's the principal job of the equipment supplier as such. The gentleman has to guide you.
Yeah.
What is the mandatory requirement of this thing? How the system has to be carried out? That's the responsibility of the manufacturer as such, equipment manufacturer.
So you certainly can discuss with the expert, they can guide you. And of course, he has given the idea. Vendors who has installed, he certainly will tell you how it is done. They are established methodology. It is not his choice.
Yeah.
They are a standard reference method which is being followed. So it will be done. You can discuss with them. You will get some idea. Of course, you will not be able to do it yourself.
Yeah.
But you will get the idea how to do it. And sir, with respect to the question you asked, there are advanced now systems where you can make the hole perfectly without losing the refractory. That is one. But there's alternative of this is you will not necessarily need to install in the stack. If there is no provision or there is no feasibility to install in the stack, there are other ways. What is the nearest possible point, nearest accurate point where you can install? It could be duct, but in that case, what you have to do? No, laminar flow, you will not get that in duct because duct will be shorter in length. So what they do, if it is a square or round the duct, you have to find what will the best place, maybe in between, and you have to do a stratification test. If you remember the stratification test, they make a square, make 12 boxes and check from every point. So that is just to see what is the pressure, flow in all that, and so what will be the right point to do that. So this is a process of installing in that. So that will also work. So there is alternative, and it is not only which I am saying, it is also written in the pollution monitoring document published by the CPCB. It is coined document which is called, it's running since 1882. So that is there, the provision is since 82. Any more?
Very good afternoon, sir. Myself Navakesar Visa from Hindalco Adityal from ABG Group. Actually, I want to know, do you have any standard procedure to check the alignment of CMS system for the various industries? Alignment of CMS systems.
Okay. So, in the guidelines, so they are clearly given how it has to be installed, where it has been, what kind of alignment you are supposed to follow. It's clearly there in the guidelines itself, CPCB guidelines. You just go through the guidelines, you will get the total clarity over the issue. Okay.
That guideline, as Reddy Saab said it very clearly, the guideline has a picture. I had shown that picture. So it says clearly where you have to install, at what angle, if you have multiple equipments to be installed, what angle, at what distance, how much distance from each other, it is all given. It is it is not only for India, it is all over the world, because that physics doesn't change. That is being followed.
Here I have to clarify, this location, basically it's more concern for the PM, particular matter. As far as gases matter is concerned, location have not much influence as such. I can't say that no influence, not much influence. Please keep that in the mind, okay?
PM is most important because gas can also have different gas, also have different density. So there could be influence, but normally it is more sensitive for the PM.
Yeah, to avoid this tampering and manipulations of data and other things, maybe PCB could give some concessions like one time in a day deviation or 30 times in a month deviation, so that more people will fall into this category. See, one time deviation fellow and 100 time deviation fellow both follow the same manipulation method. So if you give this deviation limit, concession, maybe 1 or 2 times deviation person will fall into this actual data transfer and
You have
genuine.
the right query as such.
Like this, PCB should come out with some concession.
Yeah,
Counts.
yeah.
Counts. I can say that counts.
Yeah, you have the right question as such. It needed
Suggestion is a suggestion, not a question.
Yeah, yeah. I
Thank you,
understand that. Yeah, it's the right suggestion as such. Only problem is that there is a difference of understanding between the regulators and industry. Once you have the trust, both the regulator have the trust on the industry have trust on the regulator, this problem will be solved as such. As on date, we have this kind of deficiency. That's the reason we are following the uniform things as such. Okay.
So even now, with using that data, nobody is, giving any penalty to you. So if it is exceeding, they are telling you, you correct it. Right now, it is happening.
Acceptable counts. More
Yep.
people will come into this. Maybe
So-
it's one kind of.
That is something to be debated upon. If I give you 30 concession in a month, so that will be a benchmark. So let's do 30, and after that we'll see. So it will not change. 30 doesn't change. So right now, it is even they are not asking you to do that. We are all are learning on that. So, yeah. So regulator is the right person to answer this. Yeah, it's a good. It's a good suggestion. At least we are thinking progressive. No, he's saying non-compliance.
Told, na, is there any deviations, any exceedance now and then only it is indicating the functioning of equipment. But only problem is that regulator should understand that kind of fluctuations. In the absence of that understanding, one way regulator encouraging this kind of manipulation as such.
They
So
cannot
that's a
say
need
it.
of our as such. Okay, thank you.
Thank you very much. So we have a lunch ready. We'll come back at 2 and then we'll start. Feel free to have lunch. Thank you very much. That time Cems had been started, and he was instrumental in doing that guidelines. One of the experts, even after leaving CPCB, he's being into the Cems arena and many other things in monitoring and industry, is Dr. J.S. Kamyotra. He was supposed to be here, but unfortunately he's sick, and I'm thankful to him. He managed to be online and to do his part of the work. So there are a lot of things for his introduction. So I'm just keeping it brief and handing over to Kamyotra sir. You can see the crowds now. So we have around 175 people now, around 30 Andhra Pradesh Pollution Control Board officials, around 10 vendors or suppliers. All of them remaining are from industry, Vizag and other districts. So all are handed over to you now.
And the data from this will be coming directly to the servers installed at CPCB or the state pollution control board. And based on the data that you have generated, curative action at the industries as required can be taken. So this is the format or conceptual view of the online monitoring system, where the systems are installed at the industry. The data is coming from the sensors and coming to the data loggers and the center server. But if you look into the guidelines of CPCB, it says clearly states that the data from the analyzers need to come to the servers without any IoT or any logging system in between. Yeah. So when we talk about compliance, and especially when we talk about the environmental compliance, we are talking about sustainable growth, and which imbibes the environment, equitable growth, and health and safety for its population. To achieve that, we need to have standards for the emissions or the effluent quality. And to ensure that these standards or for the emissions or effluent quality are met by the industry, we need to have good monitoring network. And the data that is collected from the monitoring network, either through the sampling and its subsequent analysis in the laboratory, need to have a credible reporting, which brings transparency in the system. People are confident, yes, that the industry is either compliant or non-compliant. To ensure that these standards are complied with, we need to have a strong regulatory framework. and at present, this is the major gap, thinning of the resources with the state pollution control and elsewhere is a better option to bring for optimization and resource management by the industry itself. And once this is done, the compliance over a long period can be ensured. And the industry can get benefit of the compliance that it's doing in terms of green tech or green industry or anything, and it can promote its image in the market. So in 2014, when the notification was issued that all the continuous emission monitoring system or effluent quality monitoring system need to be installed, the list comprised of 17 categories of highly polluting industries. In our country, the industries are categorized under 4 categories. The red category, the orange, and the white category. Under the red category, again, 17 categories of industry which have a high pollution potential are considered of specific importance. And they include like thermal power plants, caustic soda, pulp and paper, sugar, distillery, refineries, petrochemicals, smelters, steel industry, and all these. In addition to the 17 categories, it was felt that the biomedical waste facilities, the common hazardous waste facility, and the municipal solid waste treatment facilities need to install continuous emission monitoring system. In addition to that, all the industries discharging into river Ganga, known as the grossly polluting industries, were also required to install continuous emission monitoring system. To help in compliance of the directions, CPCB came out with the guidelines in 2017 and which were revised in 2018, and the affluent quality guidelines which were framed in 2014 itself. So we have guidelines for emission monitoring system, we have guidelines for the affluent quality monitoring system. The system imbibed for continuous emission monitoring comprises of the analyzers or the sensor-based system, a facility to draw sample, analyze the sample, and provide power and record of the emissions or the effluent quality on a real-time basis. The important components being the sample collection, the interface between sample collection and transportation, where if required, then the analyzer of the sensors to generate signals proportional to the concentration, system to calibrate the devices, then either we need the calibration standards or calibration gases, and then we need the data acquisition and data handling system to collect and transport the data. And in case some of the technologies or depending upon the standards, we may need required to monitor additional parameters like flow, temperatures, moisture, etc. also. So these devices also need to be incorporated in the system installed for Cems as or OCM. Now this OCMs or Cems, whatever we call them, have certain advantages as compared to the manual monitoring system. Because first thing is they provide data on the real-time basis. And once the data is available on the real-time basis, it helps to optimize the processes. It helps to ensure that the pollution control system, that means the air pollution control devices or the effluent treatment plants, are working properly. And this is ensured as the data is available or accessible to the operator on real-time basis. The analysis of the data and its display on the portals for public awareness brings transparency in the monitoring performance, develops confidence in the public of the functioning of the system. Besides that, it helps in reducing the operating cost. When it says operating, in the cost of regulatory costs, which are hidden costs. Like in case the industry is not complying, certain penalties imposed, and presently these penalties are imposed in terms of for compliance. So these are not imbibed in the budget, and these are the hidden costs which the industry has to bear in case it is not complying. So installation of Cems helps in reduce the period when the non-compliance was there. And it will improve the compliance through self-regulation. Now the data is available on a real-time basis. It can be seen and action required can be taken to ensure that the systems are working perfectly. When the manual monitoring is there, the data available of the analysis that we conducted is available after 1 week or so. And by the time a lot of pollution has taken place, the environment has been impacted, where the industry is spending money on operating the pollution control devices without ensuring that the limits of the standards are met. When we talk about the standards, we have standards framed for all the 17 category of industries, and these standards vary based on the process. This vary based on the technology, and they vary based on the pollutants. So if we see that we have standards for aluminium, we have standards for drug industry, we have standards for power plants, refineries, the cement industry, thermal power plants, sugar industry, distillery. And it's just a glass of the standards if we see for the basic drug. For incinerator, we have the standards of the PM, SCL, and all this. Now the technologies for monitoring cannot be uniform. Every matrix that is emitted from the industry has different constituents. It may contain high moisture, it may contain high dust levels, it may contain corrosive gases, it may contain gases which are soluble in water. So the same technology for monitoring cannot be used by all the industries. The technology has to be matrix specific depending upon the concentration of the pollutants which are released, the presence of moisture, the presence of dust level, the temperature, the velocity, the diameter of the stack, and all this govern the technology that needs to adopt it for monitoring. So now we have standard, if you see, basic drugs, we have for the cement plant. In cement plant, again, we have various categorization. Rotary kiln without co-processing, rotary kiln with co-processing. So you have a different range of standards, different level of standards. Then you have rotary kiln with co-processing. And vertical shaft kiln, we have different technologies to monitor and different standards. Some of the standards are also load-based. That means they are based on the per ton of production. Like SO2 standards from sulfuric acid plant or smelters is kg per ton of production, sulfuric acid produced. So when we talk about the load-based standard and the concentration-based standard, we need to monitor additional parameter also so that we can evaluate the total emissions which are coming from the stacks. So we can see we have different standards for different sectors. And like if we see the standards now for power plants, old power plants, we have 100 milligrams. The power plants which came after up to 2016 have 50 milligrams, and which came after 2017 with 30 milligrams. Now, if we see that we have imposed limit of SO2 also, and many of the industries are installing FGD. Once they are installing FGD, the concentration of these pollutants, especially the PM, also goes down drastically. And now this low concentration of PM may not be monitored by the existing technology, and they may need to replace that and add additional technology or new technology to monitor that. So parameters and the concentration to be monitored and the matrix decide with the technology which we monitor. Our standards are based on CO2 concentration. That means they need to be corrected for CO2 correction. They need to be corrected for moisture. That means we need to monitor CO2 and moisture also in addition to the concentration of the pollutants that is being released, so that we can have corrections applied to that data which is generated from the analyzer. Now this 12% correction is for most of the fuels which are used like coal, carbon-based fuel, but for other it can be different. And like in the case of hazardous waste incinerator, it's 11% oxygen on dry basis. In case of power plants also, it's based on dry basis of oxygen, 3% or 6%. Yeah. So when we talk about the issues with the Cems implementation, the first thing is what is the technology? Because we discussed that the technology will depend upon the matrix of the pollutants that are in the flue gases which are emitted from the stack, the concentration of this flue gas, pollutants, the moisture content, the temperature, the stack tire, it all will decide that what is the technology. And this technology has to be specific to the emissions that are being released. Once the technology is identified, the question comes where to install. We are talking about isokinetic condition. That means where the gases which are going from the stack are nearly, when we do the sampling at the location, they are the same concentration we are getting in our sample. So the sampling has to be at the isokinetic, and the installation is very important. So it should be, as per our criteria, it should be 8D from the top, bottom, where the inlet to stack is there, and 2D from the top side. But in case such a scenario is not available, we need to go for stratification studies and come up with a factor and use that factor for collection, concentration, calculation of the dust. Once the systems are installed, the important thing is the calibration. For particulate matter, isokinetic sampling is the alternate for calibration, whereas the gaseous samplers can be calibrated by known concentration of gas. And when we have identified the system, these need to be tested for the field performance over a period of time, how they behave. And then we have the good data acquisition system, the data handling system, where the true data that is coming from the sensor is transferred to the servers. Based on the data that is received at the server, the accidents or violation level is estimated and assessed, and then the industry is required to ensure compliance of that. Now, these are the parameters which are specified in the guidelines by CPCB for which sensor-based or Cems are available. There are other parameters also for which the sensor-based system or the Cems have been established, but these are the most commonly used parameters for which CPCB has specified. Now, when we talk about the sampling or analysis of the emissions, we have two types of method. One is the analyzer-based or the Cems, and second is the manual method. The manual method is basically the reference method, and it is used for comparison with the sensor-based data or calibration. And then this data from the manual monitoring can also be used for predictive monitoring also. The automatic or the continuous system or the analyzer-based system, which we call as Cems, again can have two types of sampling. One, it can be installed on the stack directly, where it can collect the sample, analyze the sample. Or second is, we can bring the sample down and analyze it. In all these things, both the systems, the extractive and the in situ, we have different technologies for monitoring of particulate matter. And the sampling method also in the extractive are different. Either we can bring the sample in the same condition it is generated, so that no moisture condenses and the sample is received in the same situation as it is released, or we can dilute the sample so that the impact of the condensation is negligible. So these two methods, we have additional methods also, which for sampling, if you see. both the methods have their advantages and disadvantages. When we talk about the sampling system which is fixed on the stack, now this system is exposed to stack conditions. This is also exposed to the environmental conditions, and the temperature and humidity impact the monitoring. Then system being installed at a height, the calibration issues and maintenance issues, because nobody like to go there every day and check whether the system is working perfectly or not. In that regard, the in situ has certain advantages also. It's simple. The sampling and the sample are transferred, and there is minimum distance. So no separate system is required to ensure that the sample is maintained in the same condition. We don't need any separate housing. It's very cheap. And most of the Cems for particulate matter are of in situ type. Extractive sampling has their own challenges. The sample has to be drawn isokinetically. Then there is a large distance between the sample drawn and sample analyzed. The system has certain advantages also, that we can analyze the wet stacks. Measurement ranges can be maximized. Size fractionalization is possible. And the impact of the environment on the system is less. So in that regard, the maintenance is less. But we have other maintenance issues when we talk about the extractive sampling. For the PM Cems, we have number of systems which are available. Some of them are listed here, like the DC tribo, the AC tribo, light scattering, opacity, then the BAM system. So they are dependent upon the various factors, like what is the velocity, what is the duct diameter, what is the control mechanism installed, what is the temperature of the stack, gases that are emitted, the moisture content, the particle size, the dust concentration, and whether the velocity is frequently varying or not. So these factors govern the type of technology that will be adopted for monitoring of the particulate matter in the stack. So I'm not going into details of this technology. So various technologies have been identified, and the summary is that we have the UV fluorescence, which we can monitor SO2, but other gases cannot be monitored simultaneously. Then for NO and NO2, we have the chemiluminescence. For CO, SCO2, we have the gas phase correlation. We have the FTI technology. It can do multiple gases, where UV fluorescence can do SO2, chemiluminescence can do NO, NO, X. Then we have the DOAS technology, differential optical absorption spectroscopy, which can do multiple parameters. Now this can be either IR based or UV based, depending upon the pollutant that to be monitored. Then we have the FID technology, then TLD, tunable laser diode. Then for oxygen measurement, we have the zirconia oxide, paramagnetic, and we have the PAS, photoacoustic spectroscopy, which can do multiple parameters. And then we have the laser optical black scatter, transmissionometry for opacity and all this. Now, all these technologies use different principles. Like when you talk about UV fluorescence or the chemiluminescence or then we need to have a different sampling system. For others, we have a different sampling system. So the sampling system varies, and most of these gases, if multiple gases are required to be analyzed, then FTIR, DOAS, TLD, and all these are available, which can also work with gases which are soluble in water, but the cost is high. And in case you want to do just a single parameter, these are not desired. Some additional parameters are required to be monitored, like the flow, where load-based standards are given, stack temperature, moisture. Then for CO2 and O2 correction, we need to monitor CO2 and O2. And wherever we are doing the extractive dilution sampling, we need to monitor, have a facility to inject calibration gas injection at the sampling point to calibrate the system. Now, all this system, when we are talking, need to be calibrated simultaneously with the sampling system. Calibration of the analyzers alone will not help in assessing the reliability of the data. CPCB guidelines very specific in this regard, and they are very clear that the health of the system needs to be monitored every day at a specific time. So when we talk about the health, we talk about the zero drift on a daily basis. And once the drift is within the acceptable limit, we don't need to calibrate on a daily basis the analyzer with a span gas. But this span gas need to be collected, concentration to be done once a week at least, or in case there is drift observed in the zero scale continuously over regularly that. In case the drift with the span is not there, it's well and good, but in case the drift is there, it needs to be calibrated with the known gases, observed next week also, and again the following week. Then the entire system needs to be recalibrated, not for single point, but multi-point calibration. And this multi-point calibration need to be done at least once in 6 months, or whenever any major repair has taken place, or the lamp has been changed, or the lamp intensity has been varied. And we expect that at least 85% time the data availability will be there. So once we have selected the systems, we have talked about the SEM. The frequently asked questions are there. That what stack need to be monitored? What are the parameters that need to be monitored? So any stack which have been consented, that means it is described in the consent and standards have been formulated, notified for that, it need to be monitored. Only those parameters need to be monitored which are specified in the consent and for which Cems availability is ensured. Other frequent question is whether we need to monitor flow, we need to monitor velocity, we need to monitor temperature, we need to monitor moisture. Yes. Only those stacks where load-based standards have been prescribed, flow or velocity is required to be monitored. Flow and velocity required to be monitored where the monitoring technology is specified as DC trigo for PM. The temperature needs to be monitored because all the calculations are based on temperature. The stack temperature is different. When the sample is coming to the analyzer, it is a different temperature. Where the sample volume is measured, it is a different temperature. And considering the basic law, physics law, P1 V1 over T1 is P2 V2 over T2. That the volume of temperature of a gas is varies with the temperature. So we need to monitor the temperature at different places. Then the question comes whether we need to monitor moisture. Wherever the fuel is not varying, then the data for moisture concentration collected through manual monitoring can be used. But for stacks of incinerators or any industry where the fuel is varying, moisture is an important parameter and need to be monitored. Wherever we are using the question comes whether we need to monitor oxygen, we need to monitor CO2. Yes. Because all our standards need to be corrected either at CO2 percentage or O2 percent. So that's why it is important that we need to monitor O2 and CO2 also. Other important thing is that whatever values we get from the analyzers or the sensor are in milligrams per normal are to be reported in milligrams per normal, whereas the values we get is in ppm. So these need to be corrected to convert to milligrams per normal meter cube. O2 and CO2 data is also required whenever we are doing the dilution extractive method of sampling. So we are very clear that what are the situations which demand monitoring of temperature, monitoring of O2, CO2, velocity, flow, moisture, and all this. The frequent question that is coming from the industry, that where we should install the sensor or the probe. So the ideal location is the laminar flow for emission monitoring. And for water, the point of sampling should be well mixed, and there should not be any control or dilution system beyond that point. And this location is very important in case of particulate matter. If isokinetic sampling is not there, we may either monitor lower concentration or higher concentration. So that's why ideal point of sampling is 8D downstream and 2D upstream from last disturbance. Just as I mentioned that in case of old stacks where this is not possible, then you have to go for stratification studies, and that's not an easy task. But we have to do and come out with a factor which can be used for assessment or estimation of the load, particulate matter load. Other questions that generally come: how to calibrate PM7? Is it required to be at different load conditions? How to vary the load condition? How many samples are required for PM7 calibration? What should be the frequency of calibration? Yes. These are some of the major questions which are generally coming from the stakeholders, the industries. The only method for comparison of PM7 data is the isokinetic. And to assess or estimate the dust load, this need to be calculated or at 3 different loads, maybe 50%, 75%, or 100%. But that's practically not possible in an operating industry. And it can only be done when industry is taking a shutdown for the maintenance or when the industry is starting up. So for any PM Cems calibration, at least 9 samples are required, 3 different load conditions to calculate the dust factor. And this dust factor need to be calculated regularly. And if the difference is not more than 20%, the same factor can continue. Otherwise, normal frequency of calibration is 6. The other question that is coming from the industry is that who will calibrate PM cell? What is the calibration? Zero span? What is that? This is the question. So as of today, only the NIBA laboratories can be considered for calibration of PM cell. And these laboratories are recognized under Environmental Protection Act, and also they have NABL certification. When we talk about the calibration, we talk about 2-point calibration. One is the zero and one is the span. Now the zero has to be checked regularly with any inert gas. And if we are just checking it, we should not call it calibration. We can say it's calibration check. And when we do calibration check, we are not doing any adjustment. We are just checking the drift. And if it is within the acceptable range, then we don't do any changes and will continue as it is. As per the CPCB guideline, the calibration check has to be done daily basis. And the span check, which is the extreme point, need to be done at least once a week. And this is with a known concentration of gas. And just to check the linearity. We have talked about the calibration, we have talked about the installation, we have talked about the parameters that require to be monitored. So the question other ask is, can we buy any instrument? As we were discussing that only those instruments which are specific to that matrix need to be installed. Now the question comes to the instrument which is installed, whether it will cover the emission limit norms which are there or not. Because like in the dilution system, the range is lower, but with the dilution, the range is enhanced. So if you see the certification of the system, the certification is for the lower limit, not for the higher limit what we are monitoring. So that's why the range of the instrument should be at least 2.5 to 3 times of the emission limit value that are standards. The calibration should be performed with a span gas at least in the range of 75 to 80% of the selected instrumental range. To assess or check the linearity, multi-point calibration is required. And this should be done at least once a year or when major repairs are taken or when regularly the drift is observed in the span or any change of lamps or change of the intensity of the lamps. We have seen that we have the extractive system of sampling, and which again deploys different methods, hot wet method, dilution system. So the question comes whether only the calibration of the analyzer will suffice or it need to be done along with the sampling system. Yes, since the sampling system forms a part of the analyzer, in case of extractive sampling, it is important that the entire system is calibrated. So now we have identified the instrument, we have identified the calibration, we know how to calibrate, where to install. The question comes, the data transmission. The data has to come on real-time basis from the analyzer to the servers of State Pollution Control Board. Now this data, which is coming, has to come without any interface in between. The mechanism has to be tamper-proof. There has to be features for online calibration so that the system's functioning or health can be checked through remote sampling. The data validations need to be recorded properly. And then there should be a dashboard with the state boards to see the data which is coming, interpret the data, and based on the data quality, if the accident is there, alerts to be issued and remedial actions required to be taken by the industry in that case. A good data system requires continuous transfer of data for display on industry website as well as transfer. Its storage effortlessly without data loss. It has to be easily deployable and help in national database and policy decision making. This is a schematic diagram how the data is coming. So we have the systems at the site which are connected through cloud or even through network, where the data is coming to the CPCB server with the facility to have calibration, diagnostic, online validation, remote access to data. All these are there. And based on the data that is coming at the CPCB server or the state servers, alarms are issued to the industry. And if these alarms are frequent, their verification or valid is done through physical inspection. The reason being, the Water Act, the Air Act, and the Air Environmental Protection Act specifies the method of sampling, and they do not envisage the data from online system which can be considered for legal action. So any data that is generated through Cems, based on that data, action cannot be taken against the industry. So that needs to be verified, or all these three acts need to be amended to incorporate the provision of initiating action based on the data generated by Cems. That means Cems has to be brought into the regulatory regime of all the three acts. Now, this is a conceptual view of the real-time data acquisition, and we'll go. We have discussed all these things, which are the challenges, like parameters to monitor, analyzers, everything we have discussed. So these are the challenges which the industry faces when they install Cems. Now, when we talk about the data visualization, examples of good data. So first thing is that whether OCM is responding and whether we need calibration verification before validation and acceptance. So we get different data, and average value is 15 minutes data is coming to CPCB. And if you see the dashboard, we can get minute to minute or second to second data also, which is in terms of signals, and just check with the data quality that is coming at CPCB. This is one of the data from one of the industries. We show how the data is coming trend. Now we see that it's not a uniform trend. There's variation, but the values are varying within a very negligible range, between 32, 32.5. So not much variation is observed. So based on this data, validation, it needs to be concluded whether the system is working perfectly, whether the process is not having much variation, and when we correlate with other parameters, we can draw the inference of the quality and reliability of the data. Now, if we see these 4 parameters of another industry, we have the ETP outlet, we have the BOD data, we have the TSS, we have the PS data, and we have the COD. Now, if you see the pH values are nearly constant, the blue line, and other line, if you see a straight line, that is a suspended solid. But if you see the other parameters, the BOD and COD show a variation, which generally is the trend which need to be there. But this data need to be validated and plausibility control done to assess the impact of SS on BOD and COD. And if that correlation is observed for a specific matrix, then the data can be considered as acceptable or satisfactory. So this data visualization will also indicate whether the system is not responding or tampered or being adjusted illegally. This requires immediate intimation to the industry and field investigation to verify the data. And this is data of one of the power plants, if you see. And the trend, sometimes it shows very low values, but at other times it shows a mild fluctuation in production. This is another example of an industry, a paper mill, where all the values are less than 30 BOD, which generally is not, because it has to show a trend. So in this case, the total accidents was only 14 values which were observed in a week. So this is the dashboard which is available at CPCB to see the data which is coming for different parameters, the stations, the number of parameters monitored, and the SMS generated. SMS are the alerts which are generated when the values exceed the standards. All the data of the industry is available in the CP server with regards to the standards prescribed, number of stacks, number of systems installed, and based on that, the SMS are generated. So all this data is collected minute to minute or in few seconds at the analyzer and transmitted to the CP service server as 15 minutes average value. And based on the examination of this 15 minutes value, the alerts are generated on the mobile registered and informed to the vendor and who is managing that system on behalf of the industry. The color coding of the alerts varies from yellow, orange, red, and purple. Now, this color coding is based on the compliance level that we are having. So, yellow is that 15 minutes average, 8 times in 24 hours. This for affluent quality. 36 yellow alerts, we have a brown color. 72 orange alerts, we have red color. And when instruments or data connectivity fail continuously for 7 days, we have the purple color. A similar system is there for the emission monitoring. Now, all these accidents, whenever observed beyond prescribed standards, are considered as violation. But sometimes what happens that when your industry is starting its operation or closing its operation, at that time you may have higher values. These values are not considered for the purpose of accident. Spikes in the concentration spread over short duration are also not considered as accident. And if these values exceed by a fact 10% of the standards or norm more than half an hour, then the industry has to take preventive action. And in case the values exceed for 1 hour or more, then the industry has to inform the board of the situation and the action being taken to ensure that the emissions values are brought back within the norm. And all these accidents exceeding will invite action in terms of SMS and email, and based on the physical verification, action will be taken. But the industry is required to take action based on the SMS or alerts received. And in case the frequent accidents is observed, that the industry is a frequent violator of the norms as indicated by the Cems value, then it also requires action by the board. And if the industry does not control the emissions, if they are exceeding, then they have to be moved towards closure. Now, the 10% of the norm for period exceeding 1 hour, the industry is immediately required towards closure. Yeah. And the values recording during calibration will not be considered as accident. So this is a very, very brief about Cems system. And to facilitate this, CPCB has come up with many guidelines, many documents which can be seen and which can help the industry to ensure compliance. These are the guidelines which are to support and help and assist. Yeah. And this was in a very brief, and if there is any question, thank you very much.
So there are some questions, sir. Here is to you.
Good afternoon, sir. First of all, thank you so much for giving such informative knowledge. So my question is, recently we have seen a lot of involvement from NGT. So how are you, tied up with NGT and how NGT is taking actions on industries and with respect to penalization and all? We have heard in between a lot of about NGT taking actions on industries.
So in any case, or application or arrival provided with the entity, in respect of industry, they are looking from the law point of view. And based on the same, they have not taken action. And all the action is taken based on the sampling conducted. I want just a clarification. Are you talking about the compensation that is levied by the NGT?
Yes. I mean, recently we have
Right?
seen they have penalized a few of the industries on content of emissions only. So I just was thinking to get a
Yeah.
clarity
So,
on that.
so we are talking about compensation, right?
No, penalization.
Yeah, penalization is the form of compensation,
Okay,
right?
yeah.
Yeah. So I just like to make something clear. If we look at the three acts, the Water Act, the Air Act, and the Environmental Protection Act, they do not have any provision of penalty. And in case any penalty is to be levied, it is to be done by the court. The board do not have power. And the NGT, honorable NGT, what they are charging up as a compensation is under the principle of polluter pay principle and precautionary principle. So once the industry is exceeding the norm, norms means the standards that have been described. So NGT is imposing fines based on the accident, service the impact on the environment and the money required for its remediation. And that power they have asked the state boards to exercise. And as a way forward to that, or to streamline that, CPCB has come out with a formula to calculate the compensation. The compensation takes into account the number of days the violation was there, the category of industry, whether it is highly polluting or low polluting, the area where the industry is located, that is the population of that city, the money required to treat that waste or control the emission. So a formula considering these aspects has been formulated by CPCB, based on which compensation is charged. But this compensation is charged considering the direction given by the NGT, taking into account the two principles, the precautionary principle and the polluter principle.
Okay, sir.
Hope I could answer your question.
Yes. So, like taking this as a revolutionary, campaign, are we trying to tie up with NGT also? With respect to Cems.
Can you repeat that last line?
So, with respect to, as this is a revolutionary cause, so, people are not aware about, and still a lot of sensitization has to happen. And NGT is also, playing a major role nowadays to control the pollution. So, the Cems is also, trying to tie up with NGT also. I am.
You see, NGT, for bringing NGT, the sense into the regulatory regime, we need to amend the three acts. Like if you go into the Water Act, in the section under sampling, it clearly says that a notice will be served to the industry by the officer of the board of its intent to take sample. Then it specifies the procedure of collecting sample. It specifies that the sample need to be divided if the industry asks. So when we talk about online system or the cell, there is no provision of issuing notice because the data is coming online. We cannot divide the sample. So that is the industry is required to transfer the data as it is. This provision need to be incorporated in the act so that the sampling or the data that is received from the cell becomes a part of the regulatory regime. Then only this is possible. So amendment has to be done irrespective whether NGT issues order or not, because this is a notification. Water Act and the Air Act have been passed by the Parliament and in the form of an act, and they prevail.
Thank you for answering my question, sir.
Any more questions?
Thank you.
No question? So, sir, thank you very much for sparing time.
Thank you.
And apology for troubling you. You
No,
are
fine.
not well, I can see it. But you made it at the last moment. Thank you very much for it. So I will not take you much of your time. I will see you back in Delhi. I will try to
Thank you very much.
compensate for your time in here. When you are not well.
Thank you very much.
Thank you very much, sir. Thank you on the behalf of the audience.
you.
I'm saying thank you.
Thank you. Thanks, everybody. Thanks, everybody.
So this was about the guidelines you have. You still can ask questions. He was the person who has done the guideline. He has worked together. So there's no other best person I can tell you with the guarantee that who can explain you about the guideline of Cems. But still you can ask question. I will try my best if I can do. Our next speaker is Son Warden. Very briefly I'm telling you about. You can. So everyone here of your speaker has 30-40 years of experience in monitoring on US EPA regulation, Son especially. And one of the interesting things, he has also served in US military in the research on toxins, etc. So he had been in Afghanistan as well. So you don't ask question about that. So it is about Cems. But he is a very nice person. He will be able to explain you. He doesn't sound like a military person. He's so soft. So he will try his best to reach out to the audience in that volume. So he's talking about quality assurance from US EPA, which is performance test methodology and all. Ask questions as much as you can. And we might have some difficulty in understanding because of the language little barrier. I will try to moderate in between if it is required. So over to you, please.
Thank you, Sanjeev. Good afternoon, everybody. you're still alive out there. All right, I'm here to talk to you about some QA test procedures that we are required to perform for certification of Cems to assure quality data. So we have a couple different parts under the regulations in the United States. We have what's referred to as Part 60, which is an older regulation which dictates some quality assurance and certification, well, not certification, but procedures to validate data and maintain, monitor integrity. So the other part of that is Part 75, which is referred to as the acid rain rules for monitoring. Anyway, Part 75 was implemented in 1990 for facilities that are subject to the acid rain program. Largely, it was initially used for energy generating units that burn coal. There are other facilities that are now pulled under this rule that burn other fuels such as biomass fuel and fuel oil and gas. So Part 75, Appendix B, establishes the types of ongoing QA tests that are required for Cems. The frequency of each type of test and the performance criteria are specified on a daily basis, monthly or quarterly and annually. So you have a daily calibration which is performed every day, and that is zero and span, and that is conducted for both single range and dual range analyzers. We have the linearity testing, which is to demonstrate that the instrument is still linear. That is done on a quarterly basis typically, or what we refer to as an operating quarter, which is a minimum of 168 hours in a quarter to qualify for that. And then on an annual basis, traditionally, we have to do a relative test accuracy audit. This is also under Part 75, allows for operational quarters, so you cannot go more than 8 consecutive quarters without doing a test. The data validation procedures are also specified under Appendix B of Part 75, and there are also some grace provisions provided, which are the 720 unit or stack operating hours for RADAs, which means you can extend beyond the traditional deadline by 720 operating hours. You have 168 unit or stack operating hours for linearity checks. This gives you the opportunity, if you are not operating during a specific quarter, you don't have 168 hours, so it's not operational, you can extend out another 168 operating hours to get that done and still maintain valid data. You have traditionally 8 clock hours for daily calibrations after startup. That calibration is for both the zero and span value, and that also includes the low and high range if you are subject to dual or using dual range analyzers. Part 75, Appendix B, includes the requirement to create a written quality assurance, quality control plan. This plan has to provide sufficient detail to tell you exactly what procedures you are using to perform the quality assurance on your instrumentation. Also, this is in a written format and also submitted electronically to the state, to the regional office of the EPA, and to the Clean Air Markets Division. This QA plan is a living document, so as your instrumentation changes and your maintenance requirements change, you will also update that. The facility must maintain a written record of certification and QA test procedures, maintenance activities, and corrective actions. The QAC plan is a living document that is updated as necessary. With the exception of QA tests conducted during conditional data periods, QA tests validate hourly Part 75 data prospectively going forward. Hourly data collected during a grace period are considered valid until the grace period test is attempted. Then, if the test has failed, data are invalidated going forward. QA tests conducted during a grace period do not eliminate or reduce the requirement to conduct additional QA tests. For instance, when a linearity check is done in a grace period, if the quarter in which the grace period test is done is a QA operating quarter, the grace period test does not satisfy the linearity check requirement for that quarter. In other words, a second test is required in that quarter. The frequency of QA/QC tests, data calibration checks, and interference checks, which the interference check is for a flow monitor only, are once every operating day where a monitor has qualified to use offline data to validate on a limited basis. One thing about daily calibrations that is unique to Part 75 over Part 60 is Part 60 has you conducting a calibration test online or offline. Part 75 does not require you to have an instrument or do a daily calibration if the unit is not operating. However, you can perform an online or an offline calibration to be used for up to 26 operating hours. So a linearity check is conducted once every QA operating quarter. The maximum interval between the tests is no more than 4 calendar quarters plus a grace period, which is 168 hours. Gas radas are an annual test traditionally. They are required under Part 75 to occur every 2 or 4 operating quarters. Depending on the results obtained in the previous test, 2 quarters of the relative accuracy. So we can frame this with it's incentivized. So if you are a low emitter and you are below 7.5%, for your RADA criteria or the absolute value, you can actually go to an annual frequency. Otherwise, Part 75 requires a semi-annual frequency if you are between 7.6% and 10%. Some alternative relative accuracy specifications are available for low emitters. Those are outside the percentage. They're in fact absolute values such as ppm based or emission rate based. A QA operating quarter means a calendar quarter in which there are at least 168 unit or stack operating hours, and the maximum time between successive RADAs if you do not have an operational quarter is 8 calendar quarters plus a grace period, which would be 720 hours in this case. Part 75, Appendix A, includes procedures for conducting RADAs, linearities, checks, 7-day calibration error tests, and cycle time tests. Part 75, or Section 7520C specifies the types of tests required for initial certification and recertification purposes. Note, data acquisition and handling systems verification requirements are part of the certification process and found in 75.2 as well. Section 3 of Appendix A provides the performance specifications that must be met for each type of Cems certification and recertification test. Note that there are alternate performance specifications for the QA/QC tests, daily calibrations, linearity checks, and RADAs for low emitters. For example, if the reference method NOx rates are less than 0.200 pound per million BTU or 86 nanograms per joule, and the relative accuracy is greater than 10%, the RADA can still be passed if the difference between the mean reference method and the mean Cems value is less than the 0.20 pound per million BTU, or 8.6 nanogram per joule, and qualify for annual testing if the difference is less than 0.015 pound per million BTU, or 6.45 nanograms per joule. There are some certification and QA test exemptions. Linearity checks are not required for sulfur dioxide and NOx analyzers with spans of less than or equal to 30 ppm, or 79.8 milligrams per standard cubic meter. 57.36 milligram per standard cubic meter. For dual range monitors, linearity checks are not required on a range that is not used during the quarter. So for example, in the United States, we can have dual range instruments, so you would have a normal operating range, and then you have a high range that would actually capture typically startup or maybe shutdown times for that boiler or whatever the process might be. So if you have a unit that's running consistently and does not have a startup and shutdown event, for example, that would exercise that high range or some sort of process upset, then you do not have to do a linearity test on that range during that quarter if it's not used. SO2 RADAs are not required for units that combust only very low sulfur fuels, such as natural gas. There is also a caveat in there for low sulfur coal, but that's typically not the case. So we have a RADA, as I mentioned, then we have a linearity check, and we have a calibration error test or daily calibration. The thing to note here is that a calibration is a hands-off procedure, so that's why it's actually a test and not necessarily considered a calibration per se. You also have a 7-day drift test that is performed during certification and recertification events, and a cycle time test, which is the response time of the analyzer through the entire system. So the gas is injected at the ground level, and it runs up through the entire system and back. So the cycle time test is one of the certification recertification test requirements for gas monitors. Please note that in the case of Part 75 and in the US, if you have a like kind analyzer recertification, if you have to replace an analyzer with the exact same thing, then you do not need to re-perform a cycle time test. Zero and upscale calibration gases are injected to determine the upscale and downscale cycle or response time. This is not to exceed 15 minutes. Starting with a stable stat gas concentration, zero gas is injected and the time it takes for 95% of the step change between the stat gas and zero gas concentrations to be achieved is the downscale cycle time. You repeat this using a high reference gas to determine the upscale cycle time. The higher of the upscale and downscale cycle times is reported as the cycle time for the monitor. And the cycle time must not exceed 15 minutes. You have a 7-day calibration test. Manual and automatic adjustments are allowed after the zero and upscale injections are made each day. However, unadjusted values must be used to determine the calibration error. Note that the calibration error limits for a 7-day test, which is part of certification and recertification, is 2.5% for SO2 and NOx monitors and 0.5% CO2 or O2 for diluent gas monitors, and 3% of the span for a flow monitor. These are twice as stringent as the daily calibration error limits, which are 5% of the span for SO2 and NOx monitors and 1% for CO2 or O2 diluent monitors. And you have a 6% drift for the span of your flow monitor. So to perform your linearity check, you use 3 calibration gases, low, mid, and high, and these are based on your range or span of the range of the lower or higher range that you're using of the instrument. You have to do 3 runs, in other words, 3 discrete passes with each gas. It has to be through the entire sampling system, including filters, scrubbers, conditioners, and as much of the sampling probe as practical. So while we would like to be able to inject the gases up at the very tip of the probe, this is typically not the case, but you can do this with other dilution extractive type systems. From Appendix A, Section 5.2, the definitions of low, mid, and high gas levels are 20 to 30% of the span for a low gas. You have 50 to 60% of the span for the mid gas, and 80 to 100% of the span for your high gas. The same gas may not be injected twice in succession. This is an important thing to note. So as you can see here, I have low, mid, high, high, mid, low, and low, mid, high. That is an unacceptable sequence. And that's because obviously they do not want you to actually follow up the same gas. They want you to run each one, it has to be a discrete injection of a dissimilar gas. The unit must be conducting fuel during the test and must be operating at conditions of typical stack temperature and pressure. And this is an important thing to note for the type of Cems that you have. While it's not necessarily as critical for an extractive wet system, or dry system, sorry, which would be extracting your gas and running it as is through the sampling system, through moisture removal system, if you have an extractive dilution system that is actually affected by stack gas temperatures. So it is important to have everything running as it would normally operate. It should also be noted that it is not necessary for the unit to be generating electricity. So as long as the stack gas temperatures are within the normal range and you have normal flow and the other parameters are consistent, that does not necessarily mean you have to be tied to the grid. For a linearity check to be accepted, for NOx and SO2, the error shall not exceed or deviate from the reference value by more than 5%. The results are also acceptable if the absolute value of the difference between the average of the monitor response values and the average of the reference values is less than or equal to 5 ppm, or 13.3 milligrams per standard cubic meter for SO2 and 9.56 milligrams per standard cubic meter of NOx. For your diluent gases such as O2 and CO2, the error shall not exceed or deviate from the reference method by more than the reference value, by more than 5%. The results are also acceptable if the absolute value of the difference between the average of the monitor response values and the average of the reference values is less than or equal to 0.5% O2 and CO2, whichever is less restrictive. And this is what you're trying to accomplish with an example linearity check, where you're trying to be within the acceptance range of the span of the analyzer. So relative accuracy test audit, which is RADA for short, A RADA is a set of simultaneous measurements made by a Cems system and a reference method or methods in order to determine the relative accuracy of the Cems. One thing that should be noted, so in the United States we have a series of test methods that are under Part 60. These test methodologies dictate and prescribe the proper procedures for using these methods. So these methods are referred to as reference methods. So for example, method 7E in Part 60 would be for NOx testing. Method 3A, for example, is for O2 or CO2. So the RA is calculated using equation A10 in Appendix A. And the parameters used in the calculation include the average Cems value, the average reference method value, the mean difference between the Cems and the reference method values, and the confidence coefficient. Each RADA must consist of at least 9 valid runs. It may consist of more than 9 valid runs. However, a maximum of 3 runs may be discarded. So for example, if you run 12 test RADA runs, of those 12 runs, 3 can be thrown out if they're the worst case. So you can optimize your data based and just use 9 test runs. However, if you had 15 RADA runs, you can only throw out 3 of those test runs, and therefore you still have 12 runs. But the minimum is 9 required. But anything going beyond 12 runs, you have to present those values or those results. Sorry. Each run of a gas or moisture monitoring system RADA must be a minimum of 21 minutes in duration. You have to perform each RADA while firing the primary fuel for the unit. For dual range analyzers, you perform the gas RADA on the range normally used for measuring emissions. In most cases, this will be the low range. Gas RADAs shall be conducted at the normal load level, low, mid, or high, as identified in the electronic monitoring plan. So under Part 75, you have to look at your previous operating data for the boiler for the previous 12 months prior to the RADA. And you divide equally into 3 distinct operating load ranges across the band, the power operating band of the unit. So you define that as a low, mid, 0 to 30%, for example, is the low operating band, 30 to 60 is the mid operating band, and 60 to 100 roughly is the high band. We track this data based on megawatts or steam output of the boiler. So when you go to conduct your RADA, you run a load check going back the 12 previous months, and you find out what your normal operating load is, and then you have the option for a second normal operating load. If this changes from what was reported previously, you need to update that in your monitoring plan. However, you are given the opportunity to use one of 2 loads for gas RADAs. Flow RADAs gets a little bit different, where a flow RADA you have to actually test on 2 normal loads. Those are the most common loads operated at. So this is an example report from one data acquisition we have. It kind of demonstrates what you're looking for here. So you have your operating level, low, mid, and high. And that range is, in this case, is based on megawatts. So you have the number of operating hours at those megawatt ranges. And then if you go to the percent of time that we're actually there, we break it down into percentages, so you can see that we're at the high, on the upper graph, or chart, I should say, we're at the high load 77% of the time. On the lower table, you can see where we are at the low load actually higher more often than we are at the high load. So in this case, that low load would be the normal operating load in this case. One thing that should also be noted is if you are above 85% on any one given load range for that year, for that 12-month period, then for a flow rata, you only have to conduct at the one load. And that gives you some freedom to not have to do a dual load flow rata. So after you've figured out your load and what's required for you to do your rata for the year, for example, the relative accuracy test, you have to determine stratification and determine whether it's present prior to actually testing. Excuse me. Stratification tests consist of a minimum of a 6-point traverse on each axis, or 12 points on the two axes that are 90 degrees apart. So you typically generally we base this on US EPA Method 1 criteria, which is the point selection criteria, and an example of that for a round duct is up in the corner, and then for a rectangular duct you would split it up that way. Or as an alternate, you have a 3-point traverse according to Part 60, Appendix B, Performance Specification 2. These are located at the designated percentage points across a single axis, which are 16.7, 50, and 83.7% of the diameter of the stack. One thing that's important to note is that in order to properly conduct a stratification test, and as required by Part 75, the unit load must remain constant, plus or minus 3%. This is something that you also have to submit with your supporting data. The amount of stratification for each pollutant and diluent present at the test elevation determines the number of sampling points for the reference method. So it's acceptable to use a 3-point traverse based on Performance Specification 2 if you're plus or minus 10% from the arithmetic average concentration for all traverse points. If no single point is plus or minus 5 ppm of the pollutant, or plus or minus 0.5% O2 or CO2 from the average. It is acceptable to use a single point traverse, which has to be 1 meter in from the wall, if you are plus or minus 5% from the arithmetic average concentration for all traverse points, or if no single point is plus or minus 3 ppm of the pollutant, or plus or minus 0.3% of the O2 or CO2 from the average. So part of one of the functions of the rata are not just to compare the relative accuracy of the Cems itself, but also under Part 75 we have what's called as a bias adjustment factor. So if your Cems is reading lower than the reference method, then the expectation is you are going to increase or put a bias adjustment factor on your Cems within the data acquisition to make that more representative in comparison to the reference method. So the bias is defined as systematic error of a system. A statistical analysis of the rata reference method and Cems test data is used to determine whether or not the Cems measurements are biased low with respect to the reference method. So in short, the EPA does not want us to underreport. The bias test is required for each SO2 and monitor and NOx monitoring system and flow monitor. If a bias test is failed, Part 75 requires a bias adjustment factor, or BAF, to be applied to each hour of subsequent Cems data. you also should note that the bias adjustment factors are not required for diluent, CO2, or O2, or moisture monitors. What is also interesting here is that the bias adjustment factor caps out at 11%. However, so if in this case, this is an example of RADA data, we see that there's a bias adjustment required because the reference method is sitting at 0.071 pound per million BTU and the Cems is at 0.07. So it nets in a 13% adjustment. So in this case, we would have an 11% adjustment. Or, I'm sorry, 1.3%. If this were a 13% adjustment, then it would be pushed up only 11%. But that is done in your data acquisition system, and it is gone. It proceeds forward until the next RADA. If you were to not have a bias adjustment factor, then you would leave that at 0, which is the case for this particular RADA. You can see that the reference method is lower than the Cems, and so therefore the bias adjustment factor is now effectively 1, so we are not correcting the data. So the reason we do a bias adjustment is because there are sources of bias within your Cems system. This can be, the probe can be affected easily by plugging and or scrubbing. So if you don't have good heat on your probe, or if you have material that is plugging the screen or blocking an orifice, then you can see issues there. You can have, your dilution probe can have contaminated dilution air, which could affect your zero, and if it's been calibrated using that contaminated air, that can set in and have a bias in there. You can have temperature, pressure, and gas density issues. You can get water entrainment if you have an extractive dry Cems, or an extractive dilution as well. If you get water for some reason into the sampling system, you can have scrubbing, you can have leaks, tubing goes bad. You can have absorption, which, for example, if you had lime breaking through at your baghouse or at your scrubber and it's collecting on the probe tip. Your conditioning system can go bad if it's no longer able to maintain the proper temperature to knock out all the water. You can get scrubbing from that, and also your calibration error can be incorrect. Some important notes: the certification of Cems are provisional until approved by the administrator. All steps must pass. It is recommended, highly recommended, although not required, to perform the RADA last in the process. For example, if you have a 7-day drift and you're doing the RADA in the middle of that 7-day drift test and it does not pass the 7-day drift test, you will have to not only take corrective action to correct your 7-day drift, but you're going to have to repeat your RADA. We also have recertification, which is required when there is a modification to the sampling system or analyzers are changed. This can be an abbreviated certification process depending on the type of instrument and what is exactly changed. One unique thing when we have talked earlier about certifications, and we will talk more about this going forward, but when it comes to laboratory accreditation, Part 75, interestingly, is the only rule right now that's been published with this requirement in it. So an air emissions testing body, or AETB, accreditation is required under Part 75 to perform gas RADAs. It is not required to perform the other quality assurance steps, but you do have to have somebody that's qualified to do a gas RADA. The AETB is a team or third party, but not necessarily a third party, but generally is a third party, that performs stack tests and demonstrates conformance with ASTM D7036. This is the process and procedure to which the AETB is declaring conformance. It does not mean that they necessarily have to be accredited by a third party, but that is the preferred option. However, it does allow for a declaration of conformance. This means that you are going to follow the specific procedures which are loosely based on ISO standards for data quality and handling. This also Part 75 also requires that a qualified individual or qualified source test individual, these are two different things, are there to oversee the test program. So a qualified individual is somebody who has taken the tests, however, has either not applied for or does not, at that point in time, qualify to become a qualified source test individual. Somebody that is a QSTI is somebody that has also demonstrated and currently performs testing. All right, well, thank you very much. I appreciate it. I know it was a bit quick, but does anybody have any questions?
Questions? If you do not ask questions, there will be questions from this lecture. And that is bound to be.
Thank you, sir. Thank you for explaining the things. The section somewhere you're mentioning 75 CEAB and all. Is that part of some standard, BS standard or US standard or what? I find here one standard, testing standard ASTM D7036-16. Is it related to that?
The ASTM standard is a standard that's published by, what is the acronym?
Oh, okay, anyway, that section's what you're showing there in some slides, 75, 70.6 C and all, are part of what, those sections?
You're asking about Part 75, where is it?
Yeah, right. He mentioned somewhere.
Part 75 is the regulation that applies to the acid rain regulations, and that is found under the U.S. Code of Federal Regulations, 40 CFR Part 75. So if you Google that, you will find it.
Okay, sir. Thank you. Thank you very much.
It's 40, it's the Code of Federal Regulation 40 Part 75.
So in our term, I'm converting into the Indian term. So in our term, we should understand there are two parts in US EPA. So they publish, which is called Code of Federal Regulation. That is their gadget. So in that Code of Federal Regulation, there is Part 75, which talks about continuous emission system, Cems. So where it has to be installed, how it is to be installed, all the details, maybe many hundreds of pages it runs into. There is another one which is Part 60. Part 60 is something similar to that. We have different norms for different industrial sectors. So what industrial sector is supposed to monitor and how to monitor is specific to some industries. So this is all the details, processes are related to that. So both are connected because every industry has to monitor, and how it has to be connected in terms of Cems, Part 75, in terms of norms or how you will install or how will you comply with that, that is Part 60.
And again, Title 40, Part 60, or Part 75. Part 60 is more general. It will affect various industries. Part 75 is mainly electric utility.
As this is to be conducted by only ACTB authorized personnel only, right? So it is mostly done by a third party, or industry does this, all these tests? And this is to be done by all these tests are
So he's asking all these tests we mentioned, all these 4 tests under performance test. So is it to be done by a certified agency, third party, or industry can do as well?
So when you are doing the 7-day drift, for example, or the calibration error, that can all be done internally, right? And the linearity checks can also be done internally. The RADA, the relative accuracy test audit, is the one that's required to be done by a certified AETB under Part 75. But that does not mean that that cannot be an internal entity. You can have an internal group within your company that conforms to these QA, QC procedures for data handling, and so it could be internal. And they could run the RADA test if you have the equipment. However, you know, I think generally speaking, you're looking at third party in some cases. So it could be either or.
So as you said that internal team also has to conform to some conformity, right? So is it some kind of test?
The testing has to be required by somebody that is a qualified individual at a minimum to perform the testing. And then the company or the group that's handling that data is also declaring that they are conforming with ASTM D7036. So it's kind of there's 2 different aspects there that the ASTM requires.
Yeah. Good evening, sir. As you said, in case of internal testing procedure, whether the facility need to be certified by any body?
That's what he said. It has to be qualified. Even the person, if you are doing that, you should be qualified to do that. Laboratory can have certification, or individual who is doing should have been certified. There is different agency for certification. Like in India has different agency, they do have separate different. No, not in India. No, in India it is not here. Any more questions? Sir.
He mentioned a lot of things on frequency of testing and all these things. How far it is, is there any interrelation between the Indian context and whatever the US aid he told? Is there any similarity, and is there any relaxation on our Indian context? Are there any guidelines for that specified by CPCB?
So, that is one of the points that I said. In Indian guidelines, we are saying that we have to go for the performance test, right? In the name of performance test, what we do? Zero in span calibration. But the performance test is about 4 tests that you heard, right? RATA, 7 days drift test, linearity test, and cycle test. All this goes into some sequence. It takes huge amount of time. That is performance test. And what we do, zero in span. Because we do not have capability, we have no expertise, and CPCB guidelines just say you have to do those tests. But the agency which is supposed to do the test, or any individual who needs to be expert in that to do the test, is not there. But this is the test, that's what I want to convey here. These are the tests which is required. That is altogether called performance test. So what we are doing, we are just making ourselves happy. So we are not doing all those tests. In future, for certainly, we may need to go into this.
Basically, I'm an instrumentation person. Since 30 years, I am into this field. But this is the first time I'm seeing this quality control requirement. These are so stringent and very important things. Maybe we'll adopt this in future, coming days, next generation, next stages. Thank you, sir. Thank you very much. Please share this document to everyone.
So now, as per this training, we are in the process of implementing out now US standards or European standards now. See, when the standards are very stringent and very, okay, it is similar to our existing standard, but there are a lot of differences there. So is there any roadmap that Indian professionals can be trained in these standards. Now, see, as of now, there are no professionals in India, as we discussed earlier.
No, so yeah, that is one of the things we are just trying to learn what US is doing. So they have expertized now, even not every US EPA, I mean, US guy is expert into all those things. There are special persons, expert person, who does this kind of test. That is what we are trying to learn. What is, first we do not know what are the tests are required to be done. So now we have learned. Then if you are interested, you can get into the further testing, you can learn and become expertise in those kind of testing. Right now we do not have the capability, but that capability is required to be. The day when our CPCB or any other MOEF will come up that these kinds of tests has to be done, people will start getting into it. Because for the laboratories or the persons, this is this kind of source of, I mean, maybe it is kind of job, but it has to be built up. You can start doing that.
Yeah, the qualification program is actually relatively new, and it came out in around 2005. Yes. But the ASTM standard came
This
out.
Cems over PEMS predictive monitoring system, which is less costly. So why we are going for Cems instead of predictive monitoring systems, which are cost low and also less laborious. So the systems are very huge. So it is very, burden for the industry, lot of burden. Why not we go for this PEMS?
Very simple, because PEMS does not work in many applications. Take any, the basis, the most important basis for PEMS, if PEMS works, is the fuel which is used. If the fuel is very constant, like gas or like oil, then you can use PEMS. You take a coal-fired plant, or you take a waste incinerator, or you take a cement plant, or any other plant which uses solid fuels, forget PEMS. It does not work. It's impossible unless you find a way to tell PEMS continuously the quality of your fuel. And that is not existing, this kind of instrumentation. So PEMS, yes, you are completely correct. PEMS is a very good alternative, but only for applications where it works, and that depends on the fuel what is used. If the fuel is constant, you can use PEMS. But don't forget, with PEMS you also need RATA, you also need your calibrations, you also need your annual calibration, or AST as it is in Europe. And after our tea break I will tell you how we do these things in Europe. That is also required, and you have to do that with a conventional instrumentation. So you need a conventional Cems to calibrate your PEMS.
One example of that is under Part 60 we have a subpart Quad K which is used for gas turbines. And one of the options is to use a predictive type parametric monitoring for that.
Most of us have already heard PEMS, right? It sounds fancy.
So, morning in one of the slides, we have seen that the standards which was last updated, I think it was in 2009, standards, emission standards by PCB, I think it was last updated in 2009. Okay, right. So nowadays many new industries are coming, new startups are coming. So have we had any assessment that whatever types of emissions the industries are emitting, so Cems is able to identify that? Or there are some new, or do we have some disadvantage also that there are some thing which SEM cannot identify?
So, I mean, CA QMS guideline that had come in 2009, it will be, it is in the process of getting updated. It will be updated now. They are in discussion and they are working on it. So that air quality is different because air quality is affected by many industry, vehicles, everything. So that is not industry specific, but some industry specific parameters is given for the air quality monitor to certain industry also, like petrochemical has specific parameters, etc. For Cems, all those industries, if new industry is coming, these all industry falls into some of the categories, 70 category or red category, and every industry has an industry specific standard. New industries which are coming, they again fall into the same notification or same direction which has been given by CPCB. So if CPCB is saying that these 17 categories has to monitor using Cems, so any industry which is coming up into red or 17, they have to follow that. Standards are fixed. Standards has been updated 3-4 years back. After almost 10 years, all the standards has been updated. It gets updated in time to time, but all those standards, industry-specific standards, has to be followed. There's a separate direction for the Cems that had come from CPCB. So those parameters which are mandated to be monitored by using Cems, those new industry has to use that, or even the old industry has to be doing that.
I am from steel plant. So my question is that there is a RATA is for gaseous pollutant and RRA for particulates in US. So thing is that Cems is okay. We are sending minute to minute data to our pollution control boards. Thing is that problem is at the source. That for gaseous we are calibrating by reference gases at known concentration. But for particulates we are doing manual isokinetic sampling. And this type of practice is having a lot of error, including selection of nozzle, having desired pump capacity, and moisture content of gas, and several other manpower errors. So is there any other method also in which other countries are working so that we can eliminate this isokinetic sampling and we can opt for a better sampling procedures so that there should be a minimum error while measuring particulate concentrations?
So in the United States, when it comes to particulate, and we do correlation testing and we do a relative accuracy assessment on that, you know, we're using already published method, EPA method 5, for example, right? And that already has some very tight tolerances that you have to meet in addition to comparing that data to your PM Cems data. And when we're talking about PM Cems data in the US, it's a little bit different than maybe what you're using here technology-wise. But the test method itself is pretty robust, and the equipment that you're using, you have some very tight tolerances there for that equipment for particulate type. But there's no easy way around particulate auditing. There's just, it's not. It is what it is. You have to sample for a certain duration of time, and you have to follow the steps for recovery and everything. So it is very much dependent on the quality of the testing team and the people that are executing it. In addition to the fact on the station side, maintenance and all of those obvious things that come associated with the particulate Cems themselves, and this is kind of one of the, you have an advantage here going forward where we don't necessarily with the EPA. For the AETB criteria, one of the objectives of that was to have that incorporated into other rules to pull that, so the requirement for qualified individuals is pulled into other testing methodologies. Right now it remains in a very narrow area, which is some continuous emissions testing. But you really it should not, even though the United States EPA is reluctant to open up these rules just to put this language in there, because we've been trying for years, but you know, I cannot emphasize enough the quality of the individuals that are actually, and their skills in the testing to be able to perform particulate testing, it should not be underestimated. I mean, there's a very high degree of value there.
You're adding something, Ronald? Switch on that. He basically asked out of his heart, this PM monitoring calibration is so complicated, is there any other option? So the answer is coming, yes.
There's not only the PM calibration is difficult. No, PM monitoring is extremely difficult. And I mean, my friend Stephen will tell you tomorrow all about PM, and I don't want to go too much ahead of him. But don't forget, PM, there are three major challenges in monitoring PM. One, we have a dual phase mixture between a solid and a gaseous fraction. And that can never be ideal, but for monitoring, for sampling, we require ideal mixture. And the second point is, look at the PM monitors which are available on the market. There is not one technology available which measures directly PM concentration. It is not existing. Every instrument uses a secondary effect. That is why a very elaborate calibration is required with gravimetric sampling. It's the only possibility that I can transform this arbitrarily data, what the analyzer produces, regardless what methodology it is, into milligrams per cubic meter. And that needs to be done very accurately, otherwise you just create something which has nothing to do with reality, or very little.
So summary is, you have to do, there is no other way. So other thing is, you as you said, that you use gas standard gas cylinder for calibration of gas. There is no standard dust, right? There is no standard dust. Dust is a mixture of different shapes, size, angles, refractive index, everything is different. So there is no standard which can match. So if there is nothing which can match and compare, you cannot do. So that's the only way. Be expert in that. Any more questions? So I think you people need tea, right? Sounds so. We can do right now.
You can tell that.
So now we have tea. After tea, we have just one more session of Roland. He will talk about European certification system, which you people have already much exposed to. And then we will end maybe by 5:30. 7:30 we have dinner here. So feel free, whoever wants, or you want to relax, you want to leave, it is fine. So there is a dinner here, 7:30 onwards. You can have and then go, up to you, but 7:30 dinner is available.
And one more important announcement is, actually the program is scheduled for 3 days. The last day, third day is for a field visit. For all practical purposes, the training program ends tomorrow itself. And the valedictory will be also held tomorrow. So those who want to make their travel plans, they can make tomorrow the travel plans. And one more constraint in field visit is, these Coromandel fertilizers, they said they limited the participants only to 30 to 40 members. So we may be excused for not taking all the persons to the industry. And those, it's a limited thing. And one more rider they put is, as they can't supply so many safety shoes, they said, preferably safety shoe, or otherwise at least shoe. Without shoe, they are not going to allow into the factory. So those who are interested for the day after tomorrow, tomorrow they can give certain names. How best we can accommodate, we will see. So tomorrow, many important sessions are there. And I really liked the session, the last session. So a lot of interaction has happened. That's good. That means you are just paying your attention. So we are, don't worry about the advancedness of the other countries, because we need not reinvent the wheel. wheel has been already invented. We'll try to utilize that, And one more specific request for all of you is, we are having instruments. There are 8,000 odd industries in Andhra Pradesh, but the industries required, who put this instrument are hardly 450 to 500 industries maximum. So, the more number of industries are added to this, we get lot of entrepreneurs, and the cost also will definitely come down, and lot of experts in calibration also will definitely come. So we learn from what they are doing. We'll try to do ourselves, whatever it is this. Only thing is, we need to have that inclination. Because, don't make any instrument like a wall clock without batteries, sir. So it will definitely show right time only 2 times in a day. But that is not our requirement. We want the time to be continuously correct time. So for that, we need a kind of commitment towards, calibration, checking whatever the methods available to us. So feel free to ask any question. సో ప్రశ్న లేనిదే ప్రగతి లేదు కాబట్టి ప్రశ్నించకపోతే మీకేమి తెలియదని అర్థం అనమాట. కాబట్టి ట్రై టు ఆస్క్ యాజ్ మెనీ యాజ్ క్వశ్చన్స్ యాజ్ పాసిబుల్, బీ ఇట్ వే వెరీ సిల్లీ సింపుల్ ఆల్సో. That means, interaction will be more and you learn something from out of that, by asking, one may be having lot of doubts in his mind. That may be clarified by the question asked by some other person. Okay, please, thank you very much. We'll break for tea and reassemble after 15 minutes.
Yes, maybe 20 minutes, 20 minutes. They take your time. So know who is not able to go for industry visit. For that, I have planned that all those taste calculation that we are supposed to do in industry, we will do here itself. So APPC will bring the equipment here, we will show you what calculation is supposed to be done, we will do here itself. So we are not losing anything. Right? So please have a tea and then come back as quickly as you can.
welcome back to the last session. You went through USEPA way of quality assurance, that is the performance test. One of the other part which our guideline says is about European way of quality assurance, which is certification. And after certification, how you assure the quality and control the quality. So for this session, we have Roland Jepek, again 30-40 years of experience into equipment manufacturing. He has been part of world's leading manufacturer. He has been into technology, defining it in monitoring, multiple other things related to coal sector as well. Most important part is I do not need to be an interpreter here because he is more Indian than me. So, into all the things, so you will be happy to interact with him. So feel free to listen. I can't count anymore that how many times he has been in India, more than 300, 400 times, more than 100, 400 times. So that's what I said, he is more Indian than me. So you will have no difficulty. Ask, feel free, interact. Over to you, Roland.
Thanks, Sanjeev. Yes, you're correct. I'm coming more to India than you do, because you live here. Okay, good afternoon. Wow, whoa, still awake. That's good, yeah. Coffee was good. Tea was good. Cookies were good. Now let's go and see what quality assurance does for us, or how we do that in Europe. Now, what are we measuring? I mean, I took a coal-fired plant here as an example, but I mean, you can take that. I know there are many other industries and put the steel plant here or the cement plant. So the effects, what is happening is more or less the same in all the industries. And we have several locations where process monitoring is done. And we have one location where legislative or stack monitoring is done. And that is what we are talking about here. Cems emission monitoring, various components from particulates, PM, to gas components, to reference values. We heard from Camille Trusser this afternoon about the necessary measurement of reference values: flow, temperature, pressure, oxygen, humidity. So that is what we are talking about. It's a very simple structure in Europe. Okay, the yellows are the regulations. There are EN 14181, there is EN 15267, EN 15249, and then there are directives, BREFs, permits, monitoring requirements, some of them generic for Europe, some of them special for individual countries. So don't take us in Europe as one country. We're as multiple countries as India is multiple countries and populations. And there are Cems instrumentation, which need to have accreditation, which need to have certification. Certification is based on EN 15267. We'll come in details to that. And they're installed in the plants. Got this wonderful thing here. They're installed in the plant. They report their data. Data reporting, EN 17255, is not finalized yet. It's in a draft, but it will be finalized relatively soon, and then this will turn yellow as well. And you see the center point. The center point is, I call it test teams. The accredited laboratories who do the primary test, the initial calibrations, the annual calibrations and annual tests. These are the center point for taking the regulation and enforcing with the industry what the regulation tells the industry to do. So, quality assurance. It's based on EN 14181 or the so-called QAL scheme. QAL, quality assurance level, has 3 steps: Qual 1, Qual 2, and Qual 3. Plus, there is something like AST, annual surveillance test. Now, we'll go into the details here, but this one is in the responsibility of the instrument manufacturer, of the analyzer manufacturer. The analyzer manufacturer, and this is the major difference between US EPA regulations and European regulations. In Europe, the analyzer manufacturer has to get its instruments certified as a type approval. Instrument A is certified to be used in plant type. Very interesting, plant type. What did we hear from Mr. Reddy, sir, this morning? Very important, the application. Where to use what instrument. That is why Qual 1 in Europe is specifically for individual industries. There are instruments that are allowed to be used in large power plants, but they are not allowed to be used in waste incinerators or in cement plants. So that is, and in the accreditation of the instrument, this is in the fine line, unfortunately. Many people don't read the fine line. They say, well, many manufacturers say, or some manufacturers say, my instrument is approved, TÜV approved, Qual 1 approved. But they don't tell you it's only approved for this, or it's only approved for that, or it's generically approved. So read the fine lines as well when you look into these Qual 1 certificates. Then, when instruments need to be installed in a plant, only Qual 1 certified instruments are allowed to be used in Europe. Full stop. If an instrument is not Qual 1 certified, you cannot use it in Europe for legislative monitoring. When you install it, then something quite similar to the RATA, what we heard before the tea break from Sean, the Qual 2 site approval, site testing has to be done. We'll go into details what it happens. And then, ongoing, there is Qual 3. Qual 3 is done by the owner of the instrument, by the operators, by the industry. It says, according to the operation manual of the instrument, you have to do this maintenance and that maintenance, et cetera, and that has to be done by the owner of the instrument. And once per year, an accredited laboratory comes in and does an annual check, the annual surveillance test. And we'll look into the details of these things, what they mean. So, starting with Qual 1. Qual 1 is, sometimes it's called the TÜV approval, or it was in the past. Now, TÜV is only one organization who does these type of approvals. It's the Qual 1 test, and it's an instrument type approval. And it has to be done by the manufacturer of the instrument. And it is very expensive. We're talking, just to give you a ballpark number, to get any kind of instrument Qual 1 certified, if everything goes right, if everything works perfect, it takes about approximately sometimes 1.5 years, and we're talking about 60 to 150,000 euros in cost for the manufacturer to get his instrument approved so that he can sell in Europe a certified instrument. Now, you can be dead sure that instruments who have Qual 1 certification and from manufacturers who spend this amount of money and time to get their instrument certified, they do their job. They work. So for that, you can be very sure about that. There is a list. It comes later on a little larger as well, an internet site where you can see all Qual 1 certified instruments which have current or expired certification. So it's the TÜV test, or unfortunately, UK left Europe. So there is also EMCERTS. EMCERTS is or CIRA is the organization in the UK. They do similar tests, but it's very, very similar what the two organizations are doing. Qual 2, as I said, after installation, Qual 2 is performed at site by an accredited laboratory, and Qual 2 does checks for the quality of the installation, for the operation of the instruments, for the accuracy, etc., etc. And this Qual 2 is not 1 or 2 or 3 sample points. Now, for example, for particulates, it can be up to 15 sample points. And very important, the instrument is Qual 2 certified to be used at that location to maximum around about 10% above the highest concentration measured during the Qual 2 certification. So if your plant is extremely clean, you might not even get certified up to your emission limit. But there are also regulations when it comes to how can I change the concentration in my stack gas. How can I, based on load, I cannot, for example, for particulates, I cannot change it by switching off a couple blades in my ESP, my electrostatic precipitator. Why? Any idea why? Anybody an idea why if I switch off blades in the precipitator, my concentration goes up? So why can I not do that for dust monitoring, for Qual 2? Because it changes the particle size fractions, and every instrument, whether it's optical or non-optical, is particle size dependent. So particle size is an interference to dust monitoring. Talking about dust monitoring is something easy. No, it's very difficult. So if I change my particle size fractions by switching off blades in my ESP, I'm completely changing my whole situation, dust monitoring situation, PM monitoring situation. So there are other possibilities which have to be done. And this qual 2 has to be repeated every 5 years, sorry. So every 5 years, a complete qual 2 has to be done. Qual 3, ongoing, as the manufacturer suggests, requires in the operation manual. By the way, operation manuals are there to be read and followed, not to be stored somewhere in a cupboard. They're an important part of the instrument. Please read them. So qual 3 is the daily or weekly zero span checks, maintenance to be done, and very important, according to European regulation, everything what an owner does on his instrument has to be documented. We'll come in the next slide, we'll come to why it has to be documented. Every step, every calibration, every zeros check, every span check, every maintenance step, every service has to be documented. Why? Because we have the annual surveillance test. Once per year, accredited laboratory comes in and does a small, short form qual 2 test, less tests, less sample points, etc., shorter time, lower amount of money to be paid. But the documentation of the qual 3 is part of the AST. So if the documentation is not complete, or if the manufacturer says maintenance every week and the owners have done maintenance every month, they fail. And if AST fails out of whatever reasons, immediately a complete qual 2 is required again. Qual 2 is much more expensive. So all owners, all instrument operators are very interested there that their qual 3 is perfect, that the instrument works perfect when the accredited laboratory comes in for AST, because otherwise they might lose a lot of money. I'm coming to an important point on the AST later on. So that's the setup of the qual scheme, qual 1, manufacture of the analyzers, qual 2, installation, RATA, installation test, qual 3, continuous service maintenance, etc., AST, every year, annual surveillance test by an accredited laboratory, and qual 2 has to be repeated every 5 years. If AST fails, immediately it has to be rectified, the instrument, and immediately a qual 2 is required. So, qual 1, according to 14181, and the performance testing, performance certifications, and principles EN 15267 with part 1, part 2, part 3, oops, sorry, part 3, come on, hello, Bill Gates, come on, work. He woke up. So part 3 is the most important part because this gives all the criteria, test procedures, etc. And I'm showing you one very small example that it is individual for every kind of pollutant, and it's individual sometimes even for the type of instruments. Then the part 4 is for mobile, portable instrumentation. The 15859 is for triboelectric qualitative monitoring. There are two load-based monitoring systems, triboelectric, purely qualitative, and electrodynamic, concentration-based. So there are two different things using similar effects. And then the data handling and data acquisition system. Data handling and data acquisition systems also have to have Qual 1 certification. So it's not that data handling in Europe is just something some software guy puts together. No, it has to have a Qual 1 certification as well. Otherwise, it cannot be used. Just one example for minimum requirement in the Qual 1 test for the instrument availability. Qual 1 test is it two parts. One is the laboratory test, interferences, temperature influence, power fluctuation influence, etc. Everything what you can do in a laboratory, plus followed, if that is successful, then followed by typically a 6-month, sometimes longer, field test where two identical instruments are installed in the plant, and they have to perform identical. And, very important for that field test of Qual 1, the instrument manufacturer is not allowed to get to the instrument, only in terms of service. If it fails, then he can come in. But what does it mean if an instrument fails? It's not available. That goes in the required availability. So that is a very important figure. Look at these numbers. Dust, PM monitoring, availability above or equal to 95% of the time, 24/7 throughout the year. And availability, calibration, maintenance, service, all goes negative in the availability, even calibration. If an instrument requires a calibration every 2 hours, it probably won't reach the 95%. It can be as good as somebody wants. So that all goes in the availability. Gas monitoring, also 95, oxygen 98, and volume flow 95 as well. So that's the overall required availability of the instruments to be demonstrated during the Qual 1 field test. That's the two home pages, and don't worry, you don't have to take pictures now. You get all the presentations later on, and you have these two home pages, the Qual 1 homepage and the MCerts homepage, where you can see which instruments have Qual 1 and which have MCerts certification, or which one is expired, because Qual 1 can also expire. Or, in worst case, it can be revoked. If an instrument manufacturer changes significantly components in his instrument, his Qual 1 certification will be revoked, and he has to run for a new Qual 1 certification. Qual 2, as I said, has to be done every 5 years. It's a field test, installation test, and the procedure, what the accredited laboratory, what our red test team from that slide does at site is it checks the installation of the Cems, checks the functional tests. It does parallel measurement with standard reference methods. And standard reference methods are defined in the site's environmental permit. There it defines also what is the standard method for this site. the data evaluation, calculation, variability, tests, how are the data reported? Are they correctly reported? In some plants they have to report online. Some plants they not real data, but hourly or daily averages. They have to report online. Others they report every month or every week. So it depends again on the plant individually. And then are the specifically for PM monitoring, the calibration factors, are they correctly stored? And is the PM calibration done correctly? And again, this has to be done by an accredited laboratory. Qual 3, that is what the manufacturer says in the operation manual, what the Qual 1 certification says in the certification description, what is the maintenance interval, what has to be done as maintenance, what has to be done as zero in span. And there is one point, last 1.5 lines, very, in my opinion, extremely important. Do with your instrument vendor go for an annual maintenance contract. Then you can be sure they will be coming and they will check the instrument and make sure that it works correctly at least once per year, and depending on how the maintenance contract is done, maybe they even come on very short notice for service and interference and repair of the instrument. So that is extremely helpful and helps you not to be the most best instrument specialist, but puts that load on the manufacturer. There are the specialists, and they can help you and can do the job and can make sure that your instruments, your Cems, is working correctly. And very important, I mean, in the meantime, CPCB suggests that here in India, when you tender for instruments, put 1 or 2 or 3 years AMC already into the tender as part of the tender documentation and as part of the required quotation. Why? Sorry for that bad word, if a lousy instrument manufacturer sells you a cheap instrument and you later on require tons of service and spare parts, he has to put it in his price, and then you'll see it. And then he's no longer L1, he's probably L500. So AST, annual surveillance test, as I said, short-term Qual 2, with less activities, lower cost, of course, from the accredited laboratory, functional tests, the parallel measurement, of course, with a standard reference method, the data evaluation calculations, and very, very, very important, I put that as point number 7, checking of the completeness of the Qual 3 documentation, so that the industry can document, look, I did all the required maintenance, zeros, spans, and I did my job. That is why the data is correct, what I delivered over the year. So that's again that. As I said, if AST fails, then a complete QAL2, the instrument has to be rectified and the complete QAL2 has to be done immediately, even if it's only after 1 year or 2 years. And that is significantly more expensive.
That is why in Europe, specifically in Germany, we're a little bit more harsh on things like that, very to the line. High service requests are always in the weeks before an AST. Sure, then the owner can be sure that the instrument has rectified, is working properly, everything is done, so that and an annual maintenance contract helps in that. That was the scheme in Europe. That is how we do things, how we make sure that instrumentation works properly. As I said, there is one major difference to the US. US approach is site approval and annual certification. In US, there is no instrument test, no type test existing, similar to Qual 1, for emission monitors. We have to be clear, for emission monitors. But that's the major difference. So again, please, if you write a tender and you want to make sure that certified instruments are offered, don't put in instruments need US EPA approval. It is not existing. There is only Qual 1 or MCERT's approval existing as instrument approval. No equivalent in the US. So if you put it, have to have US EPA approval. If the vendors are very normal, they would say, no, we can't quote. You won't get a quote. And if you get a quote, then it's a fake quote. Sorry. Okay, that's it. I tried to make up the time. I didn't want to keep you too long from our wonderful dinner tonight. So that's it. If there are any questions.
Questions?
Please.
About this quality QAL. So is there any possibility for an instrument failing at Qual 3, straight away referring to QAL1,
No,
bypassing QAL2?
The Qual 3 is the maintenance what you have to do. If an instrument fails and it's repaired, that has to be documented in Qual 3, but it doesn't mean that a Qual 2 immediately is required, only if then the AST fails. That is the annual test. If you, during your normal operation of the instrument, let's say the instrument is installed, Qual 2 all perfect, it runs and operates, and after 7 months, there is a failure of the pump, and you have to repair the pump. It has to be documented. The instrument is out of service. That goes negative in the availability. These availabilities, by the way, they're also for Qual 3 requirements. So dust monitors have to run not only in the test, in day-to-day life, 24/7 for more than 95% of the time. So that has to be documented, and then your pump is repaired, the instrument runs again, and you do your zero and spend check so that everything is fine and documented, but it does not immediately require a Qual 2 test. Only if AST would fail, then Qual 2 is.
How can we explain some car manufacturers recalling their cars from the market already sold in terms of quality assurance levels?
Can you repeat?
Many of the car manufacturers, they recall their vehicles which are already sold to the customers.
Okay.
due to some.
Okay, yeah, I was an analyzer. Yeah, okay.
So how can you explain this in terms of?
Okay, if instrument manufacturer X today realizes, the last 3 batches of my analyzer, the detector is not sensitive enough, or it has too high variations, and he recalls the instruments to put in a new detector, that goes negative in the availability of the instrument. That means if you have to take the instrument out, send it to the manufacturer, he repairs it, he sends it back, this time when you have no data, you create no data, goes negative in the availability in the instrument. That is, in such a case, I would request from the instrument manufacturer to get a replacement instrument, of course free of charge, for that period of time, so that I'm not losing data, that I still have data.
Okay, thank you, sir.
Sir, suppose I buy from a manufacturer X some instrument, and in that one electronic component failed, and he gives an equivalent, means there is a revision in the software version or a hardware version that is compatible with the instrument. Which test I require, 2 or 1? There is revision in the hardware.
Yes.
But that is compatible to the...
If it fails, and the hardware which is built in, or the software which is used, is the one under which the Qual 1 certification was given, then it's a normal failure. If a manufacturer, and when you look at the Qual 1 site, you will see that in many instruments, new revision of certification, change of software to version X. So the moment the manufacturer does any significant change to his instrument, which is Qual 1 certified, he has to get a revision or an entirely new certification. So, and that has to be documented. So they cannot, I say that's strong, they cannot just do something different. Let's say instead of a diaphragm pump, use a piston pump. That's a significant change in the gas flow. So that would require at least a recertification. Or change something in the software, operational software of the instrument. That definitely requires a recertification.
So we require a one-to-one replacement of the spare. We should not accept. He say out of stock means provide with the instrument.
Now, so the change in the equipment, if something has happened, we keep in 3 categories, test division, type O, type 1, type 2. Type O kind of changes which requires updation some kind of equipment, but that should not majorly affect the value or reading of the equipment. So you do not need recertification. Type 1, little more, but still it is not very much significantly affecting the your monitoring. You may not need, some corrections are required, may not need recertification, but type 2 is affecting significantly to the monitoring or accuracy of the equipment. You need to go for recertification, entire process again.
Or to say, if I, as a manufacturer, if I do some changes because my R&D department has some brilliant new idea, I always go back to my approval organization, to TOE or CIRA, and say, look, I plan to incorporate these changes, what is required? And then they will tell me, you need, okay, just announce it, tell us, and that's fine. We'll put it in the paperwork, or no, sorry, we need to do some more tests, or sorry, we need to do an entirely new test.
So with the replacement of your equipment, it depends how well you can bargain with your supplier, how much conditions you have put. So it was between you and you two. Questions? Yeah.
Move from here in direction.
Good evening, sir.
Good evening.
Sir, regarding in the normal lifetime for continuous air quality monitoring systems, normal lifetime, what would be the best one, sir?
Less than my lifetime.
Sir, even they quote for 5 years also we are facing
no,
troubles.
I'm better than for 5 years. No, I would say normal lifetime of Cems equipment, if they are operated correctly, serviced correctly, maintenance done as it is required, you can talk about 12 to 15 years easily. Okay, depends a little bit on the type of instrument, on the technology, etc. But typically 12 to 15 years is a good thing to look after. And I have seen dust monitors, light transmission dust monitors, still operating correctly because being serviced frequently and being maintained correctly and calibrated every year, and they were more than 20 years old. And they were still giving correct data. At that time, I worked with a manufacturer. I didn't like these instruments. I wanted to sell new ones, but...
Okay, thank you, sir.
Sir, good evening, sir. You go to the second slide, sir. In the
what kind of instruments there are. The dust monitor should be on the same level as the gas monitor.
Yes.
But if I put everything here, and the oxygen and etc. should also be here, if I put everything here, you can't read that. So
that's
now this, please don't take that that literally.
yeah, got clear, sir. Clear.
No. Sanjeev?
Yes.
Sir, for calibration of dust monitoring equipment, you said that particulate size is very important, sir. Size of the dust. In the power plants, that ES electrostatic precipitators will be, sir. For maintenance purpose, they will switch off some fields because the accumulation of dust, the wrapping electrodes and all will fail. So periodically they will be changing some, switching off some ESPs, and they will manually collect the dust and all. So because of that, the size of the particulates may change. We will be calibrating for another size.
Will change.
So for when we switch off the size of particulate, then the accuracy will go down, sir. Yeah. How we will compensate for that one?
You can't.
Means by switching off the field, we should calibrate and
I'll
practically I'm saying that.
I'll give you a little bit different example, but it goes in the same direction. Power plant, they were using 4 different coals from 4 different sources. So the specific weight of the coals, the particle size of the fly ash, they changed from coal mine 1 to 2 to 3 to 4. They had to have 4 calibration factors for their light transmission dust monitor. And depending on what coal was fired, they selected the calibration factor, because every calibration factor was different. Because particle density, when it comes to light scattering instruments, particle color, have a significant interference into the dust monitoring, into the signal. And so if that changes over time, then in the process, or it changes because I use different kinds of fuel, I can't use that. Or I have to use different calibration factors. Was that in approximately what
Yes,
you
sir.
was?
The coal fields are located at different locations.
Yeah.
Sometimes some wagons will get from one location, other wagons will come from one location. When we do the calibration in a specific period of the year, maybe some certain coal field will get in the coal. So the particle size will be different in the other times.
Yes. Yeah. Now, okay, let's put it that way. The modern ESPs, the outlet of a modern ESP is below 4 micron particle size. So, and if my particle size is below 4 micron, 4, 3, 2 microns, that will not change that significantly. Older ESPs, they can go up to 10 micron. Then there can be significant interferences. But if you realize that your fly ash has a different density, then you might have to get different calibration factors. Or you have to use a methodology which is not influenced by the density of the particles, which is existing, but unfortunately it's about 4 to 5 times the amount of money compared to a light transmission instrument. So dust monitoring is fun because it has many, many interferences.
Hi, good evening. So it may not be related to the QA part, but what is this market-driven pollution control venture? What are those?
Market-driven
pollution control ventures, which was explained in earlier presentations.
Market-driven.
He's talking about ETS. So, basic funda, you want to understand that? How does it happen? What you're asking? So, general concept is like you do in exchange, where the share prices goes up and down and all. So, same mechanism works there. So, if you are to industry, you are given a limit that for per month you can emit that SO2 100. That is the norm. He can do, as per his capacity, 60 ton. If he exceeds his norm, so you have been given a quota of 100, he has given a quota of 60. If he exceeds, he has to buy from someone who has that extra quota. So if he buys from you, he will pay you. That market price depends upon in which position you are. In the early of the month, like emission trading happens in Gujarat, you know that there is one pilot school going on. So all the industries, they have given the quota for the per month that you can emit, and that quota is based on emission norms multiplied by their hours. So if he is exceeding, he will have to buy from allowance which has been given to the industry.
Right.
And somebody who has installed better, who has better control, he will get money out of it, and who doesn't have, he will have to pay.
Right.
So it is controlled by the market.
It's controlled by the market, and it's controlled by...
No, higher limit means, it is not limit. It is compared between the similar industry, not apple to orange to apple to apple.
How many tons per day are you below your limit? These tons per day you can sell. But, the price for that is driven by the market, meaning by the availability. For example, here in India, you have an ETS for PM. In Europe, we have it for CO2. So 10, 15 years ago, CO2 allowances were awfully expensive. Today, cheap as nothing. Why? Because the industry reduced their CO2 emission, and so everybody goes to the market and wants to sell, and nobody wants to buy. So the price goes down. It's like anything what you do in trading. If supply and demand, if there is high demand, the supply is expensive. If there is low demand, the supply is cheap.
Hi, sir.
Hello?
Yeah, fine. And my doubt is actually regarding the accuracy only. Regarding that continuous monitoring instruments, you said that we don't have any standard test procedures. So normal instruments means we are having the water or chemical specification is there. For this emission, industry to industry, the emission quantity, the specification will change. Though, what is the accuracy we are getting? Without accuracy, we are measuring also no use. Whether it may be plus or minus 5%, 12%, like that, it will vary means.
The accuracy depends, the accuracy of the individual analyzer depends on the individual analyzer and on the performance of that analyzer. And it is cross-tested, cross-checked with the zero and span checks. And the repeatability. So there are several. I only showed the availability, but there are about 20 points which are checked, 20 to 30 points which are checked and which go into the performance of the instruments. So yes, and then it depends on, again, on what kind of pollutant is it what we measure. SOx, NOx is relatively simple. CO, oxygen, relatively simple. PM, bit more difficult. HF, HCl, very difficult sometimes. Depending on what is my emission source. So again, so in my whole accuracy of my Cems, there are so many pieces to the puzzle that it's impossible to give a generic answer because every piece of the puzzle plays a role, sometimes more, sometimes less. Any more questions or are you hungry? No, not hungry yet.
Sir, it was mentioned in the quality assurance level 2 regarding this data evaluation and calibration, everything. It was checked for only for 5 years. For every 5 years, it was mentioned in the presentation. So how far it can be useful for the regulatory authorities as well as the industries? 5 years is...
Yeah, okay, I did not go into these details, like what Kamiotra showed, the different industries. I did not go into these details because otherwise you would not get dinner tonight. I would talk until 10 or so. There are differences for the individual pollutants. There are differences for the individual industries. That all goes into the regulation and is listed in the regulation. So, in that part, Madam, you're perfectly correct. My presentation was not complete, but as I said, I mean, extremely difficult to be complete. I mean, here is you see that booklet. That is a short extract of the regulations. A short extract.
Okay, sir.
Any more questions? Yes.
So one more question, sir. Sir, in US standards, how the but service providing sectors has been got exemption from the pollution standards, sir. Because we are from port sector, sir. We are not productive to any things, any materials. We have got the consent from the Pollution Control Board only for providing import and export alone. But we are also following Pollution Control Board standards here. What about the US, sir?
Whew. What industry are you? I mean, that's the, sorry,
Ports.
the pollution
You also
control
have a
board.
standard for the ports, etc.
Yes.
Fortunately, we had a conversation during lunch. So with respect to the emissions from the ports, we're talking about fugitive emissions. And there in the United States, there is active monitoring to make sure that any control methods are being applied in a consistent manner. So it's more a technology or a procedures-based standard in the U.S. rather than a strict emission limit. There might be a requirement to observe various points for opacity, stay below 20%, monitor that periodically. There may be individual requirements for spraying down roads in order to keep the particulate at a controllable level. So there are requirements, there are ambient standards that need to be met, but typically those have not been part of a trading program like we might have for something else, or a continuous monitoring program, other than ambient monitors.
It would be part of ambient monitoring. Fugitive emissions are also, they're called emissions. Yes, there are emissions, but they're very low in concentration. So typically, that is, as Stephen says, this is monitored with air quality monitors, if at all. But there are no generic regulations on fugitive emissions.
So, air quality, you have only air quality norms, right?
In
that you
some,
are to put it. Of course, I was surprised how wise Cems you are talking about.
In
That
some
is
cases,
of course, it is required to. You are handling huge amount of raw materials, could be powdered, could be dirt, so it generates fugitive emission. So you are supposed to monitor and meet the air quality norms.
Yeah.
Of course, that is relevant to you. It happens everywhere in the world.
Yeah, for example, take the harbor of Hamburg. Harbor of Hamburg does not measure any of the fugitive emissions coming from the harbor, but what they measure is the fugitive emissions coming from the ships, and they are specifically sulfur dioxide, SO2 from heavy fuel oil. If that is above or certain limits, and there are certain limits what they can use, that is measured, but that is not measured because of legal requirements from the government. It's measured because of requirements from the harbor and fines set by the harbor if the emissions are too high. Yes, yeah. Nuclear. Yeah, but that is not, that is then part of industrial hygiene measurement, or worst case air quality monitoring. It's not an emission monitoring.
Sir, do all countries in the world are having emission monitoring standards? Sir?
No. No.
So one country is following and another country is not following.
White spots in the world.
If one country is following, other country is not following, it is affect to the total world, no, sir.
But I would say, excuse me, countries whom I now blacklist, but I would say developed countries have environmental norms.
So
and I consider India to be a developed country.
Which country is not following that norm, they won't have that equipment and the cost of production will be low. And who is following those norms, sir? Their purchasing and their cost of production is high, sir.
Yes, yes. But as Leslie Madam said this morning, we in the US, in Europe, we do emission monitoring since 30, 40 years. India does it since 10 years. You're doing a quantum loop in technology and what you are doing. You do it much faster than we did. We took much more time. So in that respect, that is why I say, in my opinion, India is a developed country.
Sir, as you said that Europe follows Qual 1 certifications,
Yes.
and MCerts followed by UK followed MCert. So are you Qual 1 and MCert both are different certifications?
No, as a matter of fact, you can take your instruments and get from CIRA in the UK an MCert certification, and then you take, and they're very similar scheme, and then you take your paperwork and you go to Europe, for example, to TÜV in Germany, provide the paperwork, and you get your Qual 1 certification, or vice versa. Typically, it's done the other way around. Manufacturers go for Qual 1, and then they take all their paperwork, go to CIRA, provide that. 99.9% of the cases, CIRA accepts everything, and you have your MCert certification within a couple of weeks. So no additional testing.
Thing is that, sir, in India, CPCB guidelines, the recommended certified analyzers are only from two certifications. First is from US EPA by TÜV, and second is MCerts. So there is no description of Qual 1 there.
As far as I know, there is.
I simplify.
Yes.
He's a little confused. So first of the thing, every European countries, for example, as you said, UK or some Germany, so they had separate certifying agency. Like as you said, MCert is for UK. TÜV, Rhineland, in Germany, there is TÜV Sud also, or maybe other agency. But 2004 probably onwards, there's a European standard. So all these are equivalent to each other, so they accept each other's certification. Processes are almost same. Can be different name little bit, but it is all Qual 1, Qual 2, Qual 3. CPCB is talking about US EPAs. Again, that was the mistake. US EPA, there is no US EPA certification for Cems, so don't call it US EPA certification. Certification is from EU only. US EPA has approved methods which we follow for monitoring using Cems. So CPCB guideline says you can have US EPA approved methodology, or you can have certified Cems. Certification has its process, so that process which he discussed, part is Qual 1, Qual 2, Qual 3, overall process is called certification. First of that Qual 1 is the equipment certification at manufacturer's place. Second one is Qual 2, when you are installing, you do that calibration. Qual 3 is when you are operating that tank. So Qual 1 is just part of that overall, so we call it not certification. Qual 1 is certification, but entire process is quality assurance. That's the terminology people use. Yes. I simplify.
Yes, thank you.
Any more questions? Or you want to go out in the field?
More questions?
Okay, seems we are done. I hope you had a great day. We'll have similar sessions, maybe a little tight tomorrow. But we are open for dinner 7:30 onwards. Feel free to roam around, enjoy open area. And anything you want to discuss, you get experts here. Feel free to interact. Thank you very much for the day.
Thank you.